We have found a terrestrial planet orbiting Proxima Centauri. It's the nearest exoplanet we will ever find.
It's Earth-like.
Yeah, so that's not what's interesting about it, because we've got plenty of Earth-like planets.
If it has an atmosphere, it is actually pushing up the temperature through the greenhouse effect above 0 degrees and in the liquid water habitable zone.
The James Webb Telescope has made an astonishing discovery: city lights in space. Located 7 trillion miles away, this find is not just another star or galaxy. It appears to be evidence of artificial illumination, something never seen before on this scale. Focusing on Proxima Centauri B, the closest exoplanet to Earth, the telescope revealed unusual bright lights. These lights resemble the structured glow of a city at night. This revelation raises thrilling questions about the possibility of advanced extraterrestrial civilizations. Could these lights mean we are not alone in the universe? The idea of intelligent life beyond Earth has always fascinated humanity. This discovery brings us closer to finding a definitive answer. The telescope's advanced technology detected these extraordinary lights, sparking curiosity and speculation within the scientific community. Imagine the implications if this is true. We might be on the verge of confirming civilizations with technology capable of illuminating cities on another planet. This could revolutionize our understanding of life in the cosmos and reshape our place in the universe. Exploring Proxima B. Focusing on Proxima Centauri B, the James Webb Telescope has turned its powerful gaze to the closest exoplanet to Earth. Proxima Centauri B, just 425 light-years away, has long fascinated astronomers and space enthusiasts. But what the telescope recently uncovered has left the scientific community buzzing. The James Webb Telescope detected unusual bright lights coming from Proxima Centauri B, sparking many theories and questions. These lights, resembling cityscapes from space, hint at something extraordinary. Could these be signs of an advanced alien civilization? The idea seems straight out of science fiction, yet it's backed by data from one of the most advanced space telescopes ever built. What makes this discovery even more intriguing is Proxima Centauri B itself. As the closest exoplanet, it's a prime candidate in the search for extraterrestrial life. Its proximity to its star, Proxima Centauri, places it in the habitable zone, where conditions might be right for life. The discovery of these bright lights adds a thrilling new layer to our understanding of this distant world. The lights detected are not just random flickers, but consistent and unusual enough to warrant serious consideration. They could be the result of artificial illumination, similar to how our cities light up the night. This raises profound questions about the existence of other intelligent beings in the universe and whether they might be far more advanced than we imagined. Proxima Centauri B stands as a beacon of mystery and hope, with the James Webb Telescope bringing us closer to answering if we are alone in the universe. Alien city lights unveiled. What could these mysterious city lights mean? The discovery of bright lights on Proxima Centauri B has sparked excitement among scientists and enthusiasts. Could this be the evidence of extraterrestrial life we've been seeking for decades? Imagine a distant planet where an advanced civilization thrives, building cities that shine brightly enough to be seen from trillions of miles away. These lights could be artificial, created by intelligent beings who have developed technology to illuminate their world, much like our cities are visible from space. If true, it suggests we are not alone in the universe, and that other civilizations have overcome their planetary challenges to create thriving societies. The implications are profound. It opens up the possibility that intelligent life exists beyond Earth, organizing themselves into complex societies, potentially with technologies and cultures vastly different from our own. This could lead to a new era of understanding and potentially even communication with extraterrestrial beings. However, these lights could also be natural phenomena unknown to us, caused by unique atmospheric or geological conditions on Proxima Centauri B. This means our understanding of planetary sciences could expand significantly, revealing new processes on other worlds. The discovery of these city lights pushes the boundaries of our knowledge and fuels our curiosity about whether we are alone in the universe. JWST's incredible discovery. The James Webb Space Telescope, JWST, has detected mysterious city lights on Proxima Centauri B, How did this incredible telescope make such a groundbreaking discovery? To understand, let's delve into the advanced technology behind the JWST. Unlike traditional telescopes that capture visible light, the JWST specializes in infrared imaging. This capability allows it to detect heat signatures and see through cosmic dust clouds that obscure our view. When the JWST focused on Proxima Centauri B, it picked up unusual bright lights resembling city lights. This was possible through its sophisticated infrared sensors, sensitive to the faintest heat emissions. By capturing these wavelengths, the JWST reveals details about distant objects invisible to other telescopes. The significance of this discovery is immense. Infrared imaging helps in detecting heat and analyzing exoplanet compositions. For Proxima Centauri B, the JWST's infrared capabilities allowed detailed observation of the planet's thermal emissions. This provided invaluable data on atmospheric conditions and potential habitability. A remarkable feature of the JWST is its ability to discern different light sources. This precision distinguishes artificial lights from natural phenomena. By analyzing specific patterns and intensities, researchers infer if the lights are artificial, such as city lights rather than natural sources like volcanic activity. The discovery of these lights on Proxima Centauri B has excited the scientific community. It opens new avenues for exploring extraterrestrial life and advanced civilizations. The JWST's role in this discovery highlights the importance of advanced infrared imaging in astronomy and its potential to transform our understanding of the universe. As we explore the cosmos, the JWST's detection of distant signals brings us closer to answering, are we alone in the universe? Scientists react to alien lights. The discovery of city lights on Proxima Centauri B has shocked the scientific community. This finding has ignited excitement and skepticism among experts. Many scientists are cautiously optimistic, considering the implications for our understanding of life in the universe. The idea that these lights could indicate advanced civilizations has sparked intense debates. David Kipping, an astronomer from Columbia University, offered insights into Proxima B's unique characteristics. He described the exoplanet as tricky due to its varied heating patterns, which differ from other planets. Unlike typical rocky planets, Proxima B's infrared nature contrasts sharply with its host star, Proxima Centauri. This anomaly has caught researchers' interest, highlighting the importance of the James Webb Space Telescope, JWST, in capturing these distinct heat signatures. Kipping emphasized that Proxima B's peculiar thermal emissions make it a fascinating subject for further study. The JWST's advanced infrared imaging capabilities are crucial in observing these patterns. As scientists delve deeper into Proxima B's atmospheric composition, they hope to unravel the mysteries of this enigmatic exoplanet. The possibility of discovering life or advanced civilizations on Proxima B continues to fuel scientific curiosity and ambition. Proxima B's hidden secrets. Now let's dive into Proxima B's atmospheric composition and temperature fluctuations, crucial elements that shape our understanding of this mysterious exoplanet. Proxima B, located just 425 light-years away, fascinates scientists and space enthusiasts. It's not just the city lights, but also its unique atmosphere that captures attention. Proxima B's atmosphere is a puzzle. The James Webb Telescope, JWST, is helping to solve. Unlike typical rocky planets, Proxima B has a distinct thermal profile. This anomaly intrigued researchers, leading them to use the JWST's advanced infrared imaging capabilities. The telescope's ability to detect various infrared wavelengths allows scientists to map Proxima B's thermal emissions with precision. Understanding Proxima B's temperature fluctuations is vital. Without an atmosphere, it would have extreme temperature differences between its day and night sides. An atmosphere could moderate these temperatures, creating a more stable environment. The JWST's observations provide key insights into the planet's atmospheric dynamics. These thermal emissions are influenced by Proxima B's atmospheric gases. The JWST detects subtle variations in thermal radiation, revealing the types of gases present. Greenhouse gases like carbon dioxide, methane, and water vapor could indicate a complex atmosphere capable of supporting life. This analysis is more than just curiosity. Studying Proxima B's atmosphere helps scientists understand how similar exoplanets might behave. The data from the JWST could identify other potentially habitable planets, advancing our quest to find extraterrestrial life. The JWST's role in this research is indispensable. Its technology detects faint thermal emissions, providing a clear picture of distant planets' atmospheres. This ability to observe thermal emissions in detail makes the JWST a game-changer in exoplanetary science. In summary, the atmospheric analysis of Proxima B using the JWST enhances our understanding of this exoplanet and sets the stage for future discoveries in the search for life beyond Earth. The JWST reveals the intricate dance of thermal emissions and atmospheric gases, showcasing modern astronomy's sophisticated tools and techniques. Can Proxima B host life? Proxima B, an exoplanet orbiting Proxima Centauri, has sparked curiosity about its habitability. The James Webb Space Telescope's findings provide crucial insights into this distant world. Proxima B's atmosphere holds the key to determining if life could exist there. The atmosphere of Proxima B is complex. For life to thrive, gases like oxygen, water vapor, and methane must be present. Detecting these gases would strongly indicate that Proxima B could support life. However, identifying these elements is challenging. Detecting life-supporting gases on Proxima B is difficult. The James Webb Space Telescope, with its advanced infrared imaging, helps analyze the planet's thermal emissions. This gathers data on the planet's atmosphere. Despite its technology, the JWST faces limitations. It can analyze water vapor, carbon dioxide, and methane, but struggles with detecting bonded oxygen, a vital sign of life. Proxima B's atmosphere adds another layer of complexity. The exoplanet experiences extreme temperature fluctuations due to its proximity to its star. These temperature variations affect the planet's atmospheric chemistry, complicating the determination of its habitability. Scientists explore the possibility of Proxima B having an atmosphere capable of maintaining liquid water. If the atmosphere retains enough heat, it could keep water in a liquid state, crucial for life. Seas or large bodies of water would dramatically increase the likelihood of life. In their quest, scientists capture and examine light rays passing through the planet's atmosphere. This challenging task requires precision and advanced technology. Information from these light rays provides clues about Proxima B's atmospheric conditions and potential habitability. The journey to understanding Proxima B's potential for life continues. Each discovery brings scientists closer to answering if we are alone in the universe. The challenges are immense, but the rewards promise to revolutionize our understanding of life beyond Earth. Future tech challenges. Proxima B, an exoplanet orbiting Proxima Centauri, has sparked intense curiosity about its potential habitability. The James Webb Space Telescope's recent findings offer crucial insights into this mysterious world. One exciting aspect of Proxima B is its atmosphere, which could determine if life exists there. The atmosphere of Proxima B is a complex subject. Scientists believe certain gases are essential for life, such as oxygen, water vapor, and methane. Detecting these gases would indicate Proxima B could support life. However, identifying these elements is challenging. Assessing Proxima B's habitability involves detecting these life-supporting gases. The James Webb Space Telescope, with its advanced infrared imaging, can analyze the planet's thermal emissions. This helps scientists gather data on its atmospheric composition. Despite its technology, the JWST faces limitations. It can analyze water vapor, carbon dioxide, and methane, but struggles with bonded oxygen, a vital sign of life. Proxima B's atmosphere adds another layer of difficulty. The planet experiences extreme temperature fluctuations due to its proximity to its star. These temperature variations can affect its atmospheric chemistry, complicating the determination of its ability to sustain life. Scientists are also exploring the possibility of Proxima B having an atmosphere capable of maintaining liquid water. If the atmosphere retains enough heat, it could create conditions for liquid water, crucial for life. Seas or large bodies of water would increase the likelihood of life on Proxima B. To uncover Proxima B's secrets, scientists are capturing and examining light rays passing through its atmosphere. This challenging task requires precision and advanced technology. Information from these light rays provides clues about the atmospheric conditions and potential habitability of Proxima B. The journey to understanding Proxima B's potential for supporting life is ongoing. Each discovery brings scientists closer to answering whether we are alone in the universe. The challenges are immense, but the potential rewards could revolutionize our understanding of life beyond Earth. Hunt for alien signals. The search for extraterrestrial intelligence, or SETI, is a beacon of hope for those who believe we are not alone. The SETI Institute, founded in 1984 by Jill Tarter and Thomas Pearson, is dedicated to finding cosmic company. They focus on detecting extraterrestrial radio signals which can travel across the cosmos without being scattered or absorbed. SETI's efforts are powered by the Allen Telescope Array, a collection of 42 radio telescopes in the Cascade Mountains of California. For over 3 decades, this array has listened intently for faint whispers from alien civilizations. Although no definitive results have been found, Jill Tarter remains optimistic. She envisions a future where 21st century tools accelerate the search, empowering people everywhere to join this cosmic hunt. Despite the absence of detected signals, the SETI Institute's perseverance is unwavering. Their mission inspires many to ponder the possibilities of life beyond Earth. This dedication underscores our fundamental drive to connect with the unknown and seek other intelligent beings in the universe. As technology advances, the dream of discovering extraterrestrial life continues to captivate imaginations worldwide. Proxima B's survival secrets. Proxima B, with its potential to harbor life, presents numerous challenges for habitability. One major hurdle is the extreme temperature variations. Proxima B experiences scorching days and freezing nights. This results from its close proximity to Proxima Centauri, causing intense solar radiation. The phenomenon of tidal locking adds to the difficulty. One side of Proxima B is always in daylight, the other in darkness. This causes one side to be extremely hot and the other frigidly cold. Without an atmosphere, the daytime side could become unbearably hot, and the nighttime side extraordinarily cold. Strong solar winds from Proxima Centauri pose another challenge. These winds could strip away Proxima B's atmosphere over time. Without a magnetic field to deflect the winds, essential gases needed for life could be eroded. High-energy particles, including ultraviolet rays and X-rays, further complicate the situation. This intense radiation is detrimental to the atmosphere's stability. These factors make Proxima B a tough but fascinating study for scientists. Understanding life's potential under such conditions stretches our knowledge of habitability. Ongoing observations by telescopes like the James Webb Space Telescope offer valuable insights. They slowly unravel the mysteries of this distant world. Alien survival theories. One of the most fascinating aspects of the discovery of city-like lights on Proxima Centauri B is the speculative theories about how potential alien civilizations might survive its harsh conditions. Imagine a world where intelligent beings adapt to an environment vastly different from ours, overcoming extreme challenges to thrive on this distant exoplanet. Proxima B's proximity to its star means it experiences intense solar radiation and extreme temperature variations. These conditions might seem insurmountable, but advanced alien civilizations could develop ingenious methods to survive and flourish. One theory suggests the use of vast solar panels deployed across the planet's day side. These panels would harness the abundant energy from Proxima Centauri, converting it into a sustainable power source. The energy collected by these solar panels could generate heat and light, creating habitable zones even in the planet's most hostile regions. This technology would be crucial on the planet's night side, perpetually shrouded in darkness due to tidal locking. By distributing the harvested solar energy, these civilizations could warm their environments, making them more conducive to life. Moreover, the concept of solar energy utilization might not stop at survival. Advanced societies on Proxima B could develop infrastructures powered by these solar arrays, including cities and technological hubs that light up the planet, akin to our cities on Earth. This supports the idea of their existence and explains the unusual lights detected by the James Webb Space Telescope. These speculative theories show the possible ingenuity and resilience of extraterrestrial life forms. They challenge our understanding of survival and adaptation, showing a civilization that turns obstacles into opportunities for growth. As we explore Proxima B, these theories inspire us to think beyond our limitations and consider the boundless possibilities of life in the universe. The discovery of city-like lights on Proxima Centauri B has led to intriguing theories about how potential alien civilizations might survive the planet's harsh conditions. One prominent idea suggests that advanced beings could use vast solar panels to harness energy from their star, creating habitable zones and supporting infrastructure even in extreme environments. This speculative scenario showcases the potential ingenuity of extraterrestrial life in overcoming significant challenges to thrive on this distant exoplanet. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
What exactly lies at the edge of the observable universe? Well, this has remained a mystery for centuries, fueling curiosity and speculation among scientists and enthusiasts alike. The James Webb Space Telescope holds the key to unveiling this cosmic mystery. With its powerful lenses peering deeper into space, it has recently made a groundbreaking announcement of what lies at the edge of the observable universe, the eternal enigma of cosmic frontiers. For centuries, humans have been intrigued by the mysteries at the edge of the observable universe. The James Webb Space Telescope now stands ready to uncover these secrets, serving as a beacon of knowledge in our cosmic exploration. It promises to reveal the enigmatic boundaries that have fueled our curiosity for ages. Understanding the observable universe. To start our cosmic exploration, let's understand the observable universe's complexities. This celestial stage holds stars, galaxies, and captivating wonders we can observe, providing a captivating but limited view of the vast cosmic tapestry beyond. The observable universe is vast, with mind-boggling numbers. It's estimated to be 93 billion light-years wide, and each light-year is about 5.88 trillion miles or 9.46 trillion kilometers. The scale of 546.84 billion trillion miles or 878.58 billion trillion kilometers is so immense that it challenges our ability to grasp its enormity. The echoes of the Big Bang. Ever wondered why the universe is so mind-bogglingly huge? Well, it all goes back to the beginning. The Big Bang, a colossal explosion that kick-started everything about 13.8 billion years ago. This mega event set the universe in motion, and it hasn't stopped growing since, thanks to mysterious forces like dark energy. As the universe expanded, tiny particles stuck together because of gravity, forming incredible things like stars, galaxies, and planets. Over countless years, these cosmic structures went through all sorts of changes, leading to the incredible diversity we see out there today. Even though the universe seems endless, most of it is actually empty. To put things in perspective, if we shrink our whole solar system down to the size of a quarter, the nearest star would only be about 2 soccer fields away. And that's just within our home galaxy, the Milky Way, which is just one of billions in the vast observable universe. It's like our cosmic neighborhood is part of an unimaginably huge and ever-expanding cosmic city. The temporal tapestry, light's journey and cosmic expansion. Why can't we see the entire universe in all its grandeur? Well, there are 2 things holding us back. First, light takes time to travel through space. So when we look at faraway galaxies, we're actually seeing them as they were in the past. It's like cosmic time travel. Second, imagine the universe as a giant inflating balloon. Because of this constant expansion, galaxies are drifting apart, slowly moving away from us. Eventually, they go beyond what we can observe. Now, the idea of the edge of the universe has fascinated thinkers for a long time, leading to 3 main theories. One suggests the universe is infinite, stretching out endlessly. The second theory thinks of the cosmos as finite, but without an edge, like a giant loop. And then there's the third theory, the multiverse idea. It pictures the universe like a vast tapestry with many parallel universes, each with its own unique features. So the universe, with all its secrets, remains this cosmic puzzle waiting for us to explore. A telescope beyond imagination. The James Webb Space Telescope, a super advanced tool that's about to change how we see the cosmos. This space gadget uses really powerful lenses and can see in infrared, which means it's going to teach us a ton of new things about the mysteries of space. Webb's infrared skills have already surprised us by finding universe breakers. These are huge galaxies that don't follow the usual rules we thought they did. These galaxies are like time capsules, taking us back 500 to 700 million years after the Big Bang and shaking up what we thought we knew about cosmic history. JADE's program, Unveiling the Early Cosmos. Webb is on a big mission called JADES, aiming to deeply understand the early universe. Over 80 astronomers from around the world are working together on this project, and they've uncovered almost 100,000 faraway galaxies. Each of these galaxies is like a picture capturing a moment in the universe's story. Webb's ability to study distant galaxy clusters with super accuracy goes beyond what everyone thought possible. There are exciting plans to team up with upcoming telescopes, like the Nancy Grace Roman Space Telescope, which will give us an even clearer view of early galaxy clusters. This collaboration promises to expand our cosmic knowledge and perspective in fantastic ways. Exoplanets in focus, direct observations and new horizons. Webb's incredible tools like coronagraphs and advanced instruments are changing the game in studying planets outside our solar system, especially ones like HIP 65426b. This breakthrough era lets us explore diverse planetary systems, broadening our knowledge of cosmic landscapes far beyond what we know here. But Webb doesn't stop there. It's also helping us solve puzzling mysteries about black holes and how galaxies evolve over time. By spotting the oldest black holes and delving into the early moments of the universe, Webb's infrared instruments are giving us a front row seat to the cosmic dawn and the creation of mysterious cosmic entities, offering insights like never before. The enigma of cosmic black holes, Webb's spectroscopic revelations. As Webb explores space, scientists closely study the signals from black holes. Webb's special tools look at different kinds of light, showing surprising bursts. This helps us learn a lot about how these mysterious cosmic objects are born and change over time. Webb looks really far back in time, taking pictures of baby clusters and faraway galaxies. With fancy techniques that analyze light, we're figuring out how galaxies started and changed a whole lot over cosmic history. It's like watching a big cosmic dance from the beginning. Webb's multifaceted vision, from star-forming regions to ancient wonders. The James Webb Space Telescope uses special infrared powers to take pictures of lots of different things in space. It sees stars being born far away in galaxies and old, amazing things like the Phantom Galaxy. Webb helps us learn more about the vast and varied space scenery. Launched in December 2021, the James Webb Space Telescope is ready to work for 2 amazing decades. It starts a new chapter in space exploration, doing even more than the Hubble Space Telescope before it. Scientists and regular folks are excited about what it's going to find. Webb's powerful instruments started working in June 2022 and are on a big adventure. By looking in infrared, it's finding lots of galaxies we didn't know about before. This flood of information shows how good Webb is and kicks off a fresh era of exploring space and refining our theories about it. The legacy unfolds, human curiosity and cosmic frontiers. As the James Webb Space Telescope keeps exploring space, it's changing how we see the universe. Every new discovery is like a giant leap forward, inspiring scientists, astronomers, and space fans everywhere. Webb's impact, linked to our deep curiosity about the universe, sets the stage for future generations to venture beyond what we can currently see in space. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery.
We have revolutionized our perception of the universe in a matter of months, thanks to breathtaking images taken by the James Webb Space Telescope, JWST. As the biggest telescope ever sent into orbit, the JWST has provided us with its first photographs, released on July 11, 2022, which were nothing short of magnificent. These images exposed vast, celestial landscapes of dust and gas, as well as the farthest depths of the universe, showcasing massive interacting galaxies and stars nearing the end of their lives. However, even the most incredible images are just the tip of the iceberg. Mountains of data lie behind them, ready to transform our understanding of the universe. Join us as we explore how the James Webb Telescope's terrifying new image of city lights shocks the entire world. One of JWST's scientific goals is to see into the far reaches of the universe to learn how the first galaxies formed. This is possible because it takes light billions of years to travel across our universe, allowing the JWST to observe these phenomena as they appeared billions of years ago. Astronomers measure distances in light years. The distance light can travel in a year to account for this fact. This was emphasized in the team's initial graphic, a deep field photograph presented on July 11, 2022 by US President Joe Biden while speaking from the White House. Deep fields gained notoriety when the Hubble Space Telescope focused on a single area of the sky for 10 straight days beginning on December 18, 1995. The chosen area was merely a microscopic dot, making up around 1/1,000,000th of the entire sky. Most of the 3,000 previously undiscovered objects found by Hubble were galaxies located billions of light years away. A similarly tiny area of the sky is covered by the JWST's deep field, centered on the galaxy cluster SMACS 0723. The actual galaxy SMACS 0723 is 4.6 billion light years away, and its powerful gravitational field magnifies the more distant galaxies behind it, distorting them into large arcs where the gravitational field is strongest. In one instance, it was determined that a distant galaxy's light took 13.1 billion years to reach the telescope after traveling through space. As the universe grows, the light being released stretches. The main target galaxies of the JWST have stretched visible light from their stars into the infrared due to their great distance. By gathering data at these wavelengths, astronomers can directly compare JWST views with visible light photos of nearby galaxies taken by Hubble and other telescopes. This comparison will demonstrate how galaxies develop over cosmic time, enlarging and consolidating into the structures we observe today. Even more astounding than the sheer number of galaxies in the JWST's first deep field image is how quickly it was captured, in only hours as opposed to days. Practically wherever it searches, the JWST cannot help but find galaxies. Galaxy clusters are not the only objects acting as magnifying lenses. Scientists used the JWST to capture an image of a pair of galaxies designated VV191 to study how the light from one altered as it went through the other. The results of this investigation will reveal the properties of the intervening galaxies' dust, galaxies, and black holes. Stephan's quintet, a condensed collection of galaxies, was depicted in one of the JWST's initial photos. 4 galaxies in this group are gravitationally interacting with one another because they are so close to one another. The grouping's 5th galaxy merely seems nearby. In actuality, it is considerably closer to us and merely happens to lie in the same line of sight. Together, the quartet of interacting galaxies forms a laboratory where astronomers can investigate how galaxies interact and merge with each other. Such mergers were prevalent in the early universe, serving as the main pathway for galaxies to develop into the enormous star cities we see today. Supermassive black holes, one of which is present in the center of every galaxy, are also assumed to have grown as a result of these mergers. The JWST examined Stephan's quintet using its NIRCam and MIRI sensors. The MIRI photos specifically caught astronomers off guard because the galaxy's forms were not what they had anticipated. Another astounding result for the MIRI instrument came from the Phantom Galaxy M74. This spiral galaxy, 32 million light-years from Earth, is nearly face-on to us, making it a favorite for researching the enormous spiral arms that give spiral galaxies their name. However, no one has ever seen it so plainly before. For the first time, the spiral arms where star formation is occurring can be seen extending down into the galaxy's core. Collaborations will be a key focus, fusing the JWST's new observations with those from existing observatories to unlock a deeper understanding of the astronomical objects being examined. This collaboration will not only lead to new discoveries, but also enhance our understanding of known phenomena. The life cycle of stars, seeing deeply into the clouds where stars are formed, is one area in which infrared astronomy shines. Dust particles, molecules, and atoms scatter less light at longer wavelengths, making the very objects that obscure our vision at visible wavelengths become almost transparent in the infrared. Another image from the JWST was NIRCAM's observation of the 7,500 light-year distance star-forming area NGC 3324 in the Carina Nebula. Although it is just gas and dust being sculpted by starlight, the Carina Nebula appears as a landscape. Using infrared, it is incredible to look inside it, revealing what was once hidden in all its splendor. It was given the name the Cosmic Cliffs because the vast gaseous cliffs resembled a mountain range. It is actually the edge of a massive hole being worn away by the powerful ultraviolet radiation from young stars. The Hubble Space Telescope's famous image of the Pillars of Creation, star-forming regions in the Eagle Nebula, is one of its most well-known images. The JWST has recently observed this same region with its NIRCAM and MIRI instruments, allowing it to see deeper than ever before into the vast star nebula. The sporadic bright orange features that appear towards the tips of the fingers. In these images are shockwaves from newborn stars starting to produce energy through nuclear fusion. These intense processes blast huge jets of material, colliding with the dusty cocoons surrounding each star and exposing the developing star to the rest of the universe. Switching from the near-infrared image to MIRI's mid-infrared region reveals a similar but distinct landscape. The majority of the stars vanish due to their lack of brightness at these wavelengths, and emissions from naturally occurring compounds known as polycyclic aromatic hydrocarbons accentuate the dusty pillars. Occasionally, brilliant stars can be glimpsed at the tips of the gaseous fingers. These are the young stars themselves, possibly surrounded by a solar system of planets. The MIRI team was surprised by the outcome, even though they had always been aware of this observation. The JWST's new views of the Pillars of Creation will allow researchers to test their understanding of star formation and enhance their computer simulations by providing more information than ever before. To better understand how galaxies replenish their star-producing capacity, it is essential to know more about the number of young stars, the distribution of their masses, and the precise amounts of gas and dust in these areas. At the other end of the stellar life cycle, the JWST has also been illuminating how stars die. Sun-like stars swell to become red giants before contracting into white dwarfs. They break apart during this collapse, ejecting their outer layers to create a planetary nebula, a moniker that is horribly inaccurate. The JWST's image of the Southern Ring Nebula demonstrates how stunning this process can be. The star periodically ejected shells of matter from its outer layers for thousands of years until it turned into a white dwarf. The remaining portion of the star then began to constrict and heat up, causing a fresh cycle of energy production which would result in a new round of pulsation and ejection of material. This continued until there was insufficient matter left to ignite nuclear fusion, resulting in the formation of a white dwarf. This is what our own sun will experience in about 4.5 billion years. Even though the JWST cannot provide a detailed image of a planet outside our solar system, it will need dedicated space expeditions with several space telescopes working together to create detailed images of exoplanets. The JWST has nonetheless captured an image of an exoplanet, HIP 65426b, which has a mass ranging from 6 to 12 times that of Jupiter and orbits its star at around 100 times the distance of Earth from the Sun. The JWST used coronagraphs on its NIRCAM and MIRI equipment to view the exoplanet, dimming the brightness of the main star to allow the surrounding stars to be seen more clearly. Astronomers also performed an observation on the exoplanet WASP-96b using the JWST's NIRSPEC instrument. The dispersion of infrared light from 0.6 to 2.8 micrometers was displayed on the resulting graph. WASP-96b is noteworthy as it frequently crosses in front of its parent star, allowing a small amount of the star's light to travel through the exoplanet's atmosphere. The JWST demonstrated that the atmosphere of WASP-96b included water vapor. Although the planet is referred to as a hot Jupiter because it orbits its star so closely that a year only lasts 3.4 days, it has a mass around half that of Jupiter in our solar system. The results are still preliminary, requiring the creation of a computer model of the planet's atmosphere to include the height and thickness of any clouds and the relative abundance of different gases. The next step in this research is to expand it to progressively smaller exoplanets, eventually analyzing planets the size of Earth. Smaller worlds have less dense atmospheres, making this more challenging, but scientists are optimistic. We seem to be at the very beginning of a thrilling journey. The images that have already been made public are more like proofs of concept than complete scientific findings. They assure us that the telescope is functioning and that significant scientific achievements will follow. Right now, it's incredibly thrilling and entertaining. Everything the JWST touches has something fresh, and they are things that make you go, wow. Thank you for watching another episode of A World to Discover. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space. We have revolutionized our perception of the universe in a matter of months, thanks to breathtaking images taken by the James Webb Space Telescope, JWST. As the biggest telescope ever sent into orbit, the JWST has provided us with its first photographs, released on July 11, 2022, which were nothing short of magnificent. These images exposed vast, celestial landscapes of dust and gas, as well as the farthest depths of the universe, showcasing massive interacting galaxies and stars nearing the end of their lives. However, even the most incredible images are just the tip of the iceberg. Mountains of data lie behind them, ready to transform our understanding of the universe. Join us as we explore how the James Webb Telescope's terrifying new image of city lights shocks the entire world. One of JWST's scientific goals is to see into the far reaches of the universe to learn how the first galaxies formed. This is possible because it takes light billions of years to travel across our universe, allowing the JWST to observe these phenomena as they appeared billions of years ago. Astronomers measure distances in light years. The distance light can travel in a year to account for this fact. This was emphasized in the team's initial graphic, a deep field photograph presented on July 11, 2022 by US President Joe Biden while speaking from the White House. Deep fields gained notoriety when the Hubble Space Telescope focused on a single area of the sky for 10 straight days beginning on December 18, 1995. The chosen area was merely a microscopic dot, making up around 1/1,000,000th of the entire sky. Most of the 3,000 previously undiscovered objects found by Hubble were galaxies located billions of light years away. A similarly tiny area of the sky is covered by the JWST's deep field, centered on the galaxy cluster SMACS 0723. The actual galaxy SMACS 0723 is 4.6 billion light-years away, and its powerful gravitational field magnifies the more distant galaxies behind it, distorting them into large arcs where the gravitational field is strongest. In one instance, it was determined that a distant galaxy's light took 13.1 billion years to reach the telescope after traveling through space. As the universe grows, the light being released stretches. The main target galaxies of the JWST have stretched visible light from their stars into the infrared due to their great distance. By gathering data at these wavelengths, astronomers can directly compare JWST views with visible light photos of nearby galaxies taken by Hubble and other telescopes. This comparison will demonstrate how galaxies develop over cosmic time, enlarging and consolidating into the structures we observe today. Even more astounding than the sheer number of galaxies in the JWST's first deep field image is how quickly it was captured, in only hours as opposed to days. Practically wherever it searches, the JWST cannot help but find galaxies. Galaxy clusters are not the only objects acting as magnifying lenses. Scientists used the JWST to capture an image of a pair of galaxies designated VV191 to study how the light from one altered as it went through the other. The results of this investigation will reveal the properties of the intervening galaxies' dust, galaxies, and black holes. Stephan's Quintet, a condensed collection of galaxies, was depicted in one of the JWST's initial photos. 4 galaxies in this group are gravitationally interacting with one another because they are so close to one another. The grouping's 5th galaxy merely seems nearby. In actuality, it is considerably closer to us and merely happens to lie in the same line of sight. Together, The quartet of interacting galaxies forms a laboratory where astronomers can investigate how galaxies interact and merge with each other. Such mergers were prevalent in the early universe, serving as the main pathway for galaxies to develop into the enormous star cities we see today. Supermassive black holes, one of which is present in the center of every galaxy, are also assumed to have grown as a result of these mergers. The JWST examined Stephan's quintet using its NIRCam and MIRI sensors. The MIRI photos specifically caught astronomers off guard because the galaxy's forms were not what they had anticipated. Another astounding result for the MIRI instrument came from the Phantom Galaxy M74. This spiral galaxy, 32 million light-years from Earth, is nearly face-on to us, making it a favorite for researching the enormous spiral arms that give spiral galaxies their name. However, no one has ever seen it so plainly before. For the first time, the spiral arms where star formation is occurring can be seen extending down into the galaxy's core. Collaborations will be a key focus, fusing the JWST's new observations with those from existing observatories to unlock a deeper understanding of the astronomical objects being examined. This collaboration will not only lead to new discoveries, but also enhance our understanding of known phenomena. The life cycle of stars, seeing deeply into the clouds where stars are formed, is one area in which infrared astronomy shines. Dust particles, molecules, and atoms scatter less light at longer wavelengths, making the very objects that obscure our vision at visible wavelengths become almost transparent in the infrared. Another image from the JWST was NIRCam's observation of the 7,500 light-year distance star-forming area NGC 3324 in the Carina Nebula. Although it is just gas and dust being sculpted by starlight, the Carina Nebula appears as a landscape. Using infrared, it is incredible to look inside it, revealing what was once hidden in all its splendor. It was given the name the Cosmic Cliffs because the vast gaseous cliffs resembled a mountain range. It is actually the edge of a massive hole being worn away by the powerful ultraviolet radiation from young stars. The Hubble Space Telescope's famous image of the Pillars of Creation, star-forming regions in the Eagle Nebula, is one of its most well-known images. The JWST has recently observed this same region with its NIRCam and MIRI instruments, allowing it to see deeper than ever before into the vast star nebula. The sporadic bright orange features that appear towards the tips of the fingers in these images are shockwaves from newborn stars starting to produce energy through nuclear fusion. These intense processes blast huge jets of material, colliding with the dusty cocoons surrounding each star and exposing the developing star to the rest of the universe. Switching from the near-infrared image to MIRI's mid-infrared region reveals a similar but distinct landscape. The majority of the stars vanish due to their lack of brightness at these wavelengths, and emissions from naturally occurring compounds known as polycyclic aromatic hydrocarbons accentuate the dusty pillars. Occasionally, brilliant stars can be glimpsed at the tips of the gaseous fingers. These are the young stars themselves, possibly surrounded by a solar system of planets. The MIRI team was surprised by the outcome, even though they had always been aware of this observation. The JWST's new views of the Pillars of Creation will allow researchers to test their understanding of star formation and enhance their computer simulations by providing more information than ever before. To better understand how galaxies replenish their star-producing capacity, it is essential to know more about the number of young stars, the distribution of their masses, and the precise amounts of gas and dust in these areas. At the other end of the stellar life cycle, the JWST has also been illuminating how stars die. Sun-like stars swell to become red giants before contracting into white dwarfs. They break apart during this collapse, ejecting their outer layers to create a planetary nebula, a moniker that is horribly inaccurate. The JWST's image of the Southern Ring Nebula demonstrates how stunning this process can be. The star periodically ejected shells of matter from its outer layers for thousands of years until it turned into a white dwarf. The remaining portion of the star then began to constrict and heat up, causing a fresh cycle of energy production which would result in a new round of pulsation and ejection of material. This continued until there was insufficient matter left to ignite nuclear fusion, resulting in the formation of a white dwarf. This is what our own sun will experience in about 4.5 billion years. Even though the JWST cannot provide a detailed image of a planet outside our solar system, it will need dedicated space expeditions with several space telescopes working together to create detailed images of exoplanets. The JWST has nonetheless captured an image of an exoplanet, HIP 65426b, which has a mass ranging from 6 to 12 times that of Jupiter and orbits its star at around 100 times the distance of Earth from the Sun. The JWST used coronagraphs on its NIRCam and MIRI equipment to view the exoplanet, dimming the brightness of the main star to allow the surrounding stars to be seen more clearly. Astronomers also performed an observation on the exoplanet WASP-96b using the JWST's NIRSPEC instrument. The dispersion of infrared light from 0.6 to 2.8 micrometers was displayed on the resulting graph. WASP-96b is noteworthy as it frequently crosses in front of its parent star, allowing a small amount of the star's light to travel through the exoplanet's atmosphere. The JWST demonstrated that the atmosphere of WASP-96b included water vapor. Although the planet is referred to as a hot Jupiter because it orbits its star so closely that a year only lasts 3.4 days, it has a mass around half that of Jupiter in our solar system. The results are still preliminary, requiring the creation of a computer model of the planet's atmosphere to include the height and thickness of any clouds and the relative abundance of different gases. The next step in this research is to expand it to progressively smaller exoplanets, eventually analyzing planets the size of Earth. Smaller worlds have less dense atmospheres, making this more challenging, but scientists are optimistic. We seem to be at the very beginning of a thrilling journey. The images that have already been made public are more like proofs of concept than complete scientific findings. They assure us that the telescope is functioning and that significant scientific achievements will follow. Right now, it's incredibly thrilling and entertaining. Everything the JWST touches has something fresh, and they are things that make you go, wow. Thank you for watching another episode of A World to Discover. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.
We physicists have waited 100 years since 1916 for this photograph.
Today, we're diving into one of the universe's most enigmatic phenomena, black holes. But did you know that the journey to understanding these cosmic mysteries began over a century ago? Let's rewind to 1916, a pivotal year in the world of physics. This was when Albert Einstein, a name synonymous with genius, introduced the world to his groundbreaking theory of general relativity. It wasn't just a set of complex equations. It laid the foundation for predicting the existence of something absolutely mind-boggling: black holes. In Einstein's universe, space and time were interwoven into a fabric, warped and curved by the mass of objects. Imagine the universe as a trampoline, and planets and stars as heavy balls placed on it, creating dips and curves. Now, Einstein's equations hinted at places where this fabric wasn't just curved, but punctured, creating a well so deep that nothing, not even light, could escape. These were the theoretical black holes. Fast forward to the 1960s, a time of great scientific strides, but also when the existence of black holes moved from theoretical physics into observational astronomy. This shift happened not in some distant galaxy, but right in our own Milky Way, in the Cygnus constellation. Discovery of Cygnus X-1. Let's set our sights on Cygnus X-1, the very first identified black hole, a discovery that not only confirmed Einstein's theories, but also opened a new chapter in astrophysics. Cygnus X-1 is situated in the constellation of Cygnus, the Swan, lying around 6,000 light-years away from Earth. When astronomers first laid eyes on this enigmatic object in the 1960s, it was like nothing they had ever seen. Here was a celestial body, incredibly dense and powerful, exerting such a strong gravitational pull that not even light, the fastest thing in the universe, could escape its grasp. This was the moment of truth, a direct nod to Einstein's predictions about the existence of such exotic objects in the universe. The discovery of Cygnus X-1 was a watershed moment. It validated the complex mathematics of general relativity in a tangible way. Einstein, decades earlier, had imagined these bizarre objects in his equations. But now, we had real, observable evidence. This was no longer just theoretical physics, it was astrophysical reality. Characteristics of black holes. What makes black holes truly fascinating is their immense gravitational pull. Imagine a force so intense that it warps the very fabric of space and time around it. This is the reality of a black hole. Their gravity is so strong because of their incredibly dense core. They are not just a hole in space, but a region where matter has been compressed to an almost unimaginable density, creating a gravitational field beyond anything we experience in our daily lives. But there's more to a black hole than just its powerful pull. Scientists believe that these cosmic enigmas are composed of 3 distinct layers, each more intriguing than the last. Let's unravel these layers one by one. First, we have the event horizon. Think of it as the boundary of a black hole, the point of no return. Once anything crosses this threshold, be it a speck of dust or a beam of light, there is no coming back. It's the ultimate one-way street, leading directly to the heart of the black hole. Next up is the photon sphere. This is a region just outside the event horizon, where the gravitational pull is so strong that photons, or particles of light, actually orbit the black hole. And finally, at the core of the black hole, lies the singularity. This is where the laws of physics as we know them start to break down. The singularity is a point of infinite density, where all the black hole's mass is concentrated. But when did we have the first photograph of a black hole? First photograph of a black hole. Let's turn the pages of space exploration to a historic moment in 2021, a year that will forever be etched in the annals of astronomy. This was the year when scientists achieved something once thought impossible, capturing the first clear photograph of a black hole, the M87 black hole. M87, a giant elliptical galaxy in the Virgo constellation, became the center of attention as astronomers from around the globe collaborated for a monumental task. Using the Event Horizon Telescope, a planet-scale array of 8 ground-based radio telescopes forged through international collaboration, they focused on the heart of this distant galaxy. The result was nothing short of breathtaking. For the first time, we had visual proof of a black hole's existence. This wasn't just a blurry image, but a clear, detailed photograph showing the black hole's shadow against a backdrop of glowing gas, the event horizon illuminated by the very light struggling to escape the black hole's grasp. Black holes in the Milky Way. Did you know that lurking within its vast expanse, hidden from direct view, there could be over 100 million black holes? Let's explore this astonishing possibility and what it means for our understanding of the universe. The Milky Way, our galactic home, is a colossal spiral of stars, gas, and dust. But within this swirling mass, there lies a hidden population of black holes. Estimates, based on rigorous scientific research, suggest a staggering number over 100 million of these enigmatic objects. But here's the catch: black holes are incredibly elusive. They don't emit light or radiation that we can easily detect. Instead, their presence is felt through their immense gravitational influence on nearby stars and gas. The challenge in detecting these cosmic behemoths lies in their very nature being the ultimate vanishing act in the universe. The idea that our galaxy is teeming with black holes is not just a curiosity, it has profound implications for our understanding of stellar evolution, galactic dynamics, and even the ultimate fate of the universe. Theories on black holes. One of the most accepted theories is that black holes are born from the remnants of massive stars. Picture a star many times the mass of our Sun, burning through its nuclear fuel. As it reaches the end of its life, it undergoes a spectacular supernova explosion, casting off its outer layers. What remains is the core, collapsing under its own gravity. If the core's mass is sufficient, it collapses to a point of infinite density, a singularity, encased within an event horizon. And thus, a black hole is born. Moving on to a more complex scenario, we encounter the Kerr solution, a fascinating twist in black hole theory. Proposed by mathematician Roy Kerr, This solution suggests that not all black holes are static. Imagine a black hole spinning at an incredible speed. This rotation leads to the formation of a ring of fire or a thin disk around the singularity, a region known as the egosphere. Here, the laws of physics get even weirder, as the black hole spin drags the very fabric of spacetime along with it. This brings us over to wormholes. Wormholes in spacetime. Imagine spacetime as a two-dimensional sheet. Normally, we'd travel across this sheet to move from one point to another. But what if this sheet could fold, bringing distant points closer? A wormhole is like a tunnel that bridges this gap, a shortcut through the cosmos. The idea stems from Einstein's theory of general relativity, which allows for the bending and folding of spacetime under extreme conditions, such as those found near black holes. The concept of wormholes is a fascinating solution to Einstein's field equations. However, it's one thing to exist on paper and quite another in reality. One of the biggest challenges is stability. Theoretical models suggest that wormholes, if they exist, are incredibly unstable. As soon as any matter, even a single photon, enters a wormhole, it would collapse, making traversal impossible with our current understanding and technology. Despite these challenges, the idea of wormholes continues to be a subject of intense speculation and study. They raise questions about the fundamental nature of the universe and our place within it. Could wormholes be the key to interstellar or even intergalactic travel? Could they enable us to achieve what is currently beyond the realm of possibility? Superstring theory. One of the most ambitious and mind-bending concepts ever proposed is superstring theory. This revolutionary idea, explored by renowned physicists like Michio Kaku, seeks to weave together the fabric of our understanding of the universe. Superstring theory presents itself as a potential theory of everything, uniting Einstein's theory of gravity, which governs the cosmos, with quantum theory, which explains the behavior of the smallest particles in the universe. This unification has been a holy grail in physics, a quest to find a single framework that explains all fundamental forces and particles. At the heart of superstring theory is a beautifully simple yet profound idea. What if the fundamental particles we know, electrons, quarks, photons, are not point-like dots but rather tiny, vibrating strings? Each string's vibration determines the particle's properties, much like different notes emerge from different vibrations of a guitar string. Here's where it gets even more fascinating. Superstring theory proposes that the universe isn't limited to the 4 dimensions of space and time that we experience, 3 of space and 1 of time. Instead, it suggests there are 10 dimensions. These extra dimensions are thought to be compactified or curled up in such a way that they are imperceptible at our scale of observation. The existence of these extra dimensions could solve many mysteries in physics. For instance, they might explain why gravity is so much weaker than the other fundamental forces. In superstring theory, gravity's apparent weakness is because it spreads out through all 10 dimensions, while other forces are confined to the 4 dimensions we experience. The nature of the universe. In this segment, we delve deep into one of the most profound mysteries that has long captivated scientists and philosophers alike: the origins of our universe. Recent hypotheses have pushed the boundaries of our imagination, suggesting scenarios that sound like they're straight out of a science fiction novel. Let's begin with a mind-bending idea. What if our universe was born from the collision of 2 separate universes? Imagine 2 vast, cosmic entities, existing in a multiverse, colliding and merging in an event of unimaginable scale and energy. This cataclysmic interaction could have sparked the birth of the universe as we know it, creating the complex tapestry of galaxies, stars, and planets. Another intriguing theory proposes that our universe might have emerged from another universe. This concept is akin to a cosmic Russian doll, where universes give birth to new universes. It's a continuous cycle of creation, where each universe has its own laws of physics and properties, vastly different from its parent. Perhaps the most startling speculation is that our entire universe could actually be inside a black hole. This theory suggests that the singularity at the center of a black hole, rather than being a point of infinite density, could be the seed of a new universe. In this scenario, every black hole in our universe could potentially be a gateway to another universe. These theories also highlight the limitations of our perception. We experience the universe in 4 dimensions, 3 of space and 1 of time. But what if there are more dimensions, as suggested by theories like superstring theory? Our 4-dimensional perception might be just a slice of a much more complex, higher-dimensional reality. Continuing research and speculation. As we push the boundaries of our knowledge, the study of black holes could lead us to uncover new aspects of space-time, matter, and the very fabric of the universe. It's a journey that intertwines the vastness of the cosmos with the subatomic world, challenging our perceptions and theories. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery.
Time and space are like a fabric, like rubber, like a trampoline net. Turn this trampoline net into a pretzel and allow yourself to go backwards in time.
Imagine that time and space are like a fabric, an interconnected web that twists and bends like a trampoline net. Now twist that net into a pretzel and imagine traveling backward through time. Ever wondered what's truly out there in the cosmos? What mysteries the universe is hiding from us? Brace yourself, because we have a revelation so groundbreaking, it's about to rewrite everything we thought we knew about the universe. American physicist Michio Kaku shares a revolutionary discovery brought to light by the James Webb Space Telescope. It's a finding so extraordinary it could challenge our very understanding of space-time. Ready to dive into a cosmic riddle that will turn your perception of the universe upside down. Let's explore how this cutting-edge telescope may have proven that time, as we understand it, might not even exist. The James Webb Telescope. Launched on Christmas Day of 2021, the James Webb Space Telescope, JWST, has quickly established itself as a pioneering force in the field of astronomy. Unlike anything before it, the JWST is equipped with highly advanced infrared instruments that allow it to peer back across the vast stretches of space and time. This marvelous piece of technology has been described as the ultimate time machine, due to its capability to observe light from the early universe, which has been traveling towards us for billions of years. What sets the JWST apart is its unprecedented resolution and sensitivity, which surpass that of its famous predecessor, the Hubble Space Telescope. These capabilities enable the JWST to detect incredibly faint and old objects in the universe, ones that have remained invisible to other telescopes until now. This deep look into the cosmos provides not just a glimpse into the distant universe, but a vivid picture of the conditions and celestial phenomena as they existed billions of years ago. The true marvel of JWST's technology lies in its intricate array of instruments and mirrors. Its primary mirror, which spans 6.5 meters in diameter, significantly exceeds Hubble's 2.4 meters, capturing more light and thus providing a sharper and more detailed view of the universe. Additionally, JWST's suite of scientific instruments is specifically designed to observe in the infrared spectrum. This allows it to see through cosmic dust clouds that block visible light, revealing the hidden nurseries where stars and planetary systems are born. These capabilities not only enhance our ability to observe known cosmic phenomena, but also open up new realms of exploration. By looking at the universe in infrared, JWST can examine the atmospheric compositions of distant exoplanets, potentially identifying signs of habitability or even life. Moreover, its sensitive instruments can trace the faint signatures of the earliest galaxies, helping astronomers to unravel how the first structures in the universe formed out of the primordial darkness. By serving as our eyes into the earliest days of the universe, the James Webb Space Telescope not only expands our understanding of the cosmos, but also deepens the mysteries that surround the origins and the fundamental nature of the universe itself. This powerful observatory is not just a telescope, it's a time portal to the ancient cosmos, offering insights that were once thought to be beyond our reach. Cosmic revelation. In a recent revelation, Michio Kaku, the renowned American physicist, shared that observations from the James Webb Space Telescope, JWST, could potentially upend our current cosmological theories. The JWST, with its sophisticated infrared gaze, has captured images of galaxies that defy the traditional narratives dictated by the Big Bang theory. These galaxies are puzzling not only because of their size and age, but also due to their sheer number. Diving into the details, these distant galaxies observed by the JWST appear too small when they should look bigger due to the stretching of space itself, an effect known as cosmic expansion. Additionally, these galaxies are far older than expected. According to conventional cosmological models, we shouldn't be able to see such mature galaxies at these early stages in the universe's history. Their existence suggests that they were formed shortly after the Big Bang, much earlier than previously thought. Furthermore, the number of these galaxies adds another layer of complexity. There are simply too many of them. Traditional models based on the Big Bang theory predict a gradual formation of galaxies, starting sparsely and increasing over time. However, the JWST's findings show a universe teeming with galaxies at a time when, supposedly, they should have been few and far between. Each of these revelations challenges the cornerstone of our understanding of the universe's evolution. The small size, advanced age, and abundance of these galaxies suggest that our current models might need significant revisions, or even potentially a complete overhaul to accommodate this new cosmic perspective. This raises thrilling questions about the very fabric of our universe and invites us to rethink our place within it. Galaxy size anomaly. Imagine peering through the most advanced telescope ever built, expecting to see distant galaxies as mere specks compared to their closer counterparts. Now imagine your surprise when these galaxies look strikingly similar in size to those that are much nearer. This is the baffling reality astronomers are grappling with, thanks to the latest observations from the James Webb Space Telescope. In the standard model of cosmology, as galaxies move away from us, their light stretches, causing them to appear smaller, a phenomenon known as the redshift effect. Yet, what the JWST has shown us flips this expectation on its head. Distant galaxies, theoretically millions of light years further than those in our galactic neighborhood, are not appearing smaller at all. They're just as large, if not identical in size, to nearby galaxies. This startling observation poses a significant challenge to the idea of an expanding universe. Why does this matter? Well, if galaxies are not appearing smaller with distance, as they theoretically should in an expanding universe, we may need to reconsider our understanding of cosmic expansion altogether. Could it be that the universe isn't stretching out as once thought? This anomaly isn't just a minor glitch. It could unravel part of the fabric of cosmological theories and compel scientists to rethink some fundamental aspects of our universe's framework. As we delve deeper into these cosmic mysteries, each observation from the JWST could potentially lead us to a new understanding of the cosmos. The redshift mystery. Diving deep into the cosmos with the James Webb Space Telescope, we encounter a concept that might twist your mind. Redshift. Redshift occurs when the light from an object in space stretches out, becoming redder as it travels toward us. This phenomenon typically signals that an object, like a galaxy, is moving away from us, and it's been a cornerstone in supporting the theory that our universe is expanding. But here's where it gets truly bewildering. The JWST has detected galaxies with incredibly high redshifts, levels that are astonishing even to seasoned astronomers. These are not just slightly higher numbers. These are redshifts that suggest these galaxies are moving away from us at speeds previously deemed impossible under the current models of the universe's expansion. What does this mean? In theory, the higher the redshift, the faster a galaxy should be racing away from us, which in turn supports the idea of an accelerating universe. However, the JWST's observations throw a wrench into this narrative. These galaxies with unexpectedly high redshifts are not behaving as they should. They're too luminous and too massive, appearing far larger and brighter than what would be expected at such tremendous distances. This redshift mystery poses a serious challenge to the standard model of cosmology. If these galaxies are so distant, yet so developed, what does this say about the speed at which our universe has been expanding? Could our understanding of cosmic expansion be a misinterpretation of the data we're observing, These are the questions that astronomers and cosmologists are now grappling with as the JWST continues to deliver data that might just rewrite the textbooks on the universe's grand-scale dynamics. The smooth galaxy problem. In the cosmic arena of galactic observation, the James Webb Space Telescope, JWST, has brought to light some stunning images that are causing astronomers to rethink well-entrenched theories about the universe. One of the most intriguing findings is the smooth, nearly pristine appearance of galaxies that appear to defy the chaotic aftermath expected from frequent cosmic collisions. According to prevailing theories, galaxies, especially in their formative years, should show signs of violent interactions, twisted shapes and scrambled features resulting from gravitational pulls and mergers with other galaxies. These cosmic collisions are thought to be part and parcel of a galaxy's life cycle, contributing to their growth and evolution. However, what JWST has shown us paints a different picture. The telescope's powerful infrared gaze has revealed galaxies that are not only unexpectedly smooth, but also maintain neat, orderly spiral arms, resembling the calm and composed galaxies much closer to us. This observation is startling because it suggests that these distant galaxies have not undergone the turbulent history that current models of universe formation and evolution predict. This smooth galaxy problem raises significant questions about our understanding of galactic formation and evolution. If these galaxies aren't showing the scars of numerous high-speed collisions, what does that say about the mechanisms we think drive cosmic structure? The lack of galactic fender benders suggests either our understanding of cosmic evolution is missing some pieces, or perhaps we need to revisit the fundamental principles that govern the universe's behavior. Each neatly spiraled galaxy, sitting billions of light years away, challenges the notion that chaos and disorder were dominant in the early universe. Instead, these galaxies hint at a different story of cosmic evolution, one that might be quieter and more orderly than we ever imagined. The Age of Stars issue. Diving deeper into the revelations of the James Webb Space Telescope, we encounter a particularly puzzling observation. Some of the stars within these distant galaxies appear to be older than the universe itself, according to traditional cosmological models. This startling finding suggests that these stars predate what we understand to be the Big Bang event, the supposed origin of all matter and energy in the universe. How can a star be older than the universe? The JWST's infrared gaze has detected light from these stars that suggests they are over 1 billion years old. This in a universe that, according to current estimates, is around 13.8 billion years old. These observations are from galaxies so distant that their light shows us a snapshot from just 400 to 500 million years after the universe began. Yet if we tally up the cosmic timeline, these stars shouldn't exist within it. They simply appear too mature for their cosmic age. This isn't just a minor hiccup in astronomical calculations, it's a profound enigma that challenges the bedrock of our understanding of cosmology. If these observations hold up under further scrutiny, they could force us to reconsider not just the timeline of the universe, but the fundamental physics underlying it. Could the Big Bang Theory need a revision, or might it even be replaced by a new model that can better accommodate these ancient stars? As scientists continue to analyze the data from JWST, the age of these stars beckons as a clue in a larger cosmic puzzle. What we thought was a settled question about the universe's beginnings may just be the first chapter in a much longer cosmic story still unfolding. Now let's dive into the Big Bang Theory in particular. Implications for Big Bang Theory. The James Webb Space Telescope has brought us to a pivotal moment in cosmology, pushing us to reconsider some of the most fundamental aspects of our universe's origins. The data collected by this powerful observatory is stirring a profound debate over the validity of the Big Bang Theory. Traditionally, this theory posits that the universe began from a singular, immensely dense and hot point approximately 13.8 billion years ago and has been expanding ever since. However, the new images from JWST reveal galaxies that are too mature and too developed to have formed in the timeline that the Big Bang Theory suggests. These galaxies, with their size, smoothness, and advanced development, suggest that they were not only formed earlier than we thought possible, but also that they have not undergone the significant changes that an expanding universe would imply. This observation directly challenges the expansion model, which underpins the Big Bang theory. If the universe has not been expanding in the way we've theorized, the foundational timeline proposed by the Big Bang becomes questionable. This contradiction could imply that either our understanding of cosmic expansion is incorrect, or that the Big Bang might not have been the singular starting point of the universe. Moreover, the existence of these ancient galaxies necessitates a re-evaluation of how we understand cosmic evolution. The implications are vast and affect not just the timeline of the universe, but also the mechanisms by which galaxies grow and evolve. The very metrics we use to gauge the age and expansion of the universe could be flawed. This shift in understanding could be as significant as when Einstein's theory of relativity redefined the laws of gravity and motion laid down by Newtonian physics, presenting a new framework for understanding the universe. The discrepancies highlighted by JWST's observations are inviting astronomers and physicists to rethink not just the cosmic timeline, but also the very fabric of cosmological principles. We are potentially on the brink of a paradigm shift, where our old models may no longer suffice to explain the new evidence unfolding before us. This is a thrilling time in cosmology, as each new image from the JWST could be the key to unlocking a new understanding of the cosmos. Time may not exist. As we dive deeper into the cosmos with the James Webb Space Telescope, we're not just challenging scientific understandings, we're also venturing into the profound philosophical implications of these discoveries. The notion that time might be an illusion is gaining traction among some of the world's leading physicists. This idea suggests that what we perceive as time, a linear progression from past to future, is not a fundamental part of the universe, but rather a human construct. This perspective is radically different from our everyday experience and prompts a re-evaluation of everything we know about the flow of events. Enter the block universe theory, a compelling alternative that posits past, present, and future as existing simultaneously. In this model, time doesn't flow. Instead, it's an additional dimension, like space. Imagine a universe where every moment is as real and concrete as any point in space. This means that every event, whether it's the signing of the Declaration of Independence or your last birthday, isn't past or forthcoming, but perpetually exists in a vast four-dimensional space-time continuum. This theory aligns with Einstein's theory of relativity, which tells us that time and space are intertwined and relative. The implications are monumental. If the block universe is real, it challenges our understanding of causality. Cause and effect might just be an illusion, crafted by our brains to make sense of our observations. In such a universe, the idea of change itself might be an illusion, since everything is already laid out in the space-time fabric. These philosophical inquiries not only deepen our understanding of the universe, but also ask us to rethink our existential narratives. What does it mean for free will, for our plans, hopes, and fears, if the future is already written and unchangeable? As we continue to explore these questions, we must remain open to the idea that the universe might be far stranger and more mysterious than we could have ever imagined. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now. The universe is teeming with planets outside our solar system, and each one offers a unique glimpse into the vast complexities of space. Enter the James Webb Space Telescope, JWST, a marvel of modern science and a beacon of hope for astronomers searching for Earth-like planets. The JWST, with its unparalleled ability to peer into the depths of space through infrared eyes, has transformed our quest to understand distant worlds. Today, we're diving deep into one of JWST's most thrilling revelations yet, the discovery of Gliese 163c. This exoplanet, located in the habitable zone of its star, presents conditions that might just support life as we know it. Gliese 163c is not just another celestial body. It represents a potential future, a new chapter in human exploration. and perhaps the answer to the age-old question, are we alone in the universe? The telescope, the James Webb Space Telescope, JWST, stands as a pinnacle of astronomical technology equipped with tools specifically designed to observe distant exoplanets with unprecedented clarity and depth. Among its suite of sophisticated instruments, the near-infrared camera, NIRCam, is pivotal. NIRCam not only captures detailed images of exoplanets, but also analyses their atmosphere by observing the light passing through it when a planet transits its star. This helps identify elements that might indicate habitable conditions or even the presence of life. Another groundbreaking instrument aboard the JWST is the Mid-Infrared Instrument, MIRI. MIRI extends the telescope's vision further into the infrared spectrum, which is crucial for studying cooler celestial objects. This capability is vital for examining the thermal characteristics of an exoplanet, providing insights into its surface temperature and conditions that are essential for assessing habitability. Equally important, the near-infrared spectrograph, NIR-SPEC, allows astronomers to dissect the chemical makeup of an exoplanet's atmosphere by spreading out the starlight into a spectrum. This tool can detect water vapor, methane, and other organic compounds, offering clues about the potential for life as we understand it. With these advanced tools, the James Webb Space Telescope not only seeks to find exoplanets, but also to explore them in a depth that was previously unimaginable, bringing us closer than ever to understanding whether planets like Gliese 163c could truly be called Earth's cousins. The discovery. The James Webb Space Telescope made headlines with its discovery of Gliese 163c, an exoplanet that quickly captured the attention of astronomers and space enthusiasts alike. This significant find was announced after JWST's detailed analysis of the star system Gliese 163, located about 49 light-years away in the constellation Dorado. Using its advanced near-infrared spectrograph, JWST was able to detect the chemical signatures and thermal properties that suggest Gliese 163c might be within the star's habitable zone. Initial observations of Gliese 163c indicated several exciting possibilities. The planet's orbit places it at just the right distance from its star to potentially allow liquid water to exist on its surface, an essential criterion for Earth-like life. Moreover, the spectral data revealed hints of an atmosphere, which is another critical factor in considering the habitability of a planet. These early findings have laid the groundwork for more detailed studies, making Gliese 163c a prime candidate in the search for life beyond Earth. Criteria for habitability. When scientists search for potentially habitable planets like Gliese 163cc, they primarily focus on three critical criteria: atmosphere, temperature, and the presence of water. Each of these elements plays a pivotal role in supporting life as we understand it. Firstly, an atmosphere is crucial because it can regulate temperature, protect biological entities from cosmic and solar radiation, and provide essential gases that biological processes might require. For instance, an atmosphere rich in oxygen and nitrogen, like Earth's, can support aerobic life forms and water cycles. Secondly, the temperature of a planet is equally significant. It must be neither too hot nor too cold, enabling the existence of liquid water on the planet's surface. This Goldilocks zone is where temperatures are just right for liquid water to exist, not so cold that it freezes solid, and not so hot that it vaporizes away. Finally, the presence of water is often considered a key marker for life. Water is a solvent in which biochemical reactions occur, crucial for life on Earth. Thus, finding signs of water on Gliese 163c, whether in vapor form in the atmosphere or as liquid on the surface, would be a strong indicator that the planet could potentially be hospitable to life forms. These criteria guide astronomers as they use the JWST to observe exoplanets across the galaxy, searching for those rare worlds where conditions might just be right for life to emerge. Characteristics of Gliese 163c. Gliese 163c stands out in the cosmic lineup of exoplanets due to its intriguing characteristics. It orbits its host star, Gliese 163, at a distance that places it squarely within the star's habitable zone, which is the region where conditions might be just right for liquid water to exist, on the planet's surface, a crucial factor for life as we understand it. The planet is approximately 6.9 times the mass of Earth, classifying it as a super-Earth. This size suggests a rocky composition with a more substantial atmosphere than our home planet, which could lead to a greenhouse effect, potentially warming the planet. The orbit of Gliese 163c is particularly fascinating. It completes a full revolution around its star in approximately 26 Earth days. Such a short orbital period indicates that the planet is much closer to its star than Earth is to the Sun. However, because Gliese 163 is a red dwarf and much cooler than our Sun, this proximity places Gliese 163c in the sweet spot for temperate conditions. Comparatively, Earth orbits the Sun every 365 days, which reflects our moderate distance from a much hotter star. The environmental conditions on Gliese 163c, inferred from its orbit and size, suggest a world that could host thick atmospheric layers capable of trapping heat. If water exists, its state, whether vapor, liquid, or ice, would heavily depend on atmospheric composition and surface pressure. In contrast, Earth's well-balanced atmosphere and magnetic field have created a stable environment where water can exist in all three states, supporting a diverse range of life forms. As we continue to study Gliese 163c, understanding these key differences and similarities will help scientists better assess the planet's potential for habitability and life. Technology behind the discovery. The James Webb Space Telescope leverages cutting-edge technology to unveil the secrets of distant worlds like Gliese 163c. Central to its success are several key instruments, each playing a vital role in this cosmic detective work. The near-infrared camera, NIRCam, is JWST's primary imager, capturing high-resolution images that bring distant stars and their orbiting planets into clearer view than ever before. This capability is crucial for spotting minute changes in brightness and position that hint at the presence of exoplanets. Additionally, the mid-infrared instrument, MIRI, provides new insights into the thermal characteristics of Gliese 163c, allowing scientists to analyze the heat signatures that differentiate it from its stellar background. MIRI's sensitivity to longer wavelengths is ideal for studying cooler objects in space, making it indispensable for assessing the habitability of colder, Earth-like planets. Another essential tool is the near-infrared spectrograph, NIRSpec, which can disperse the light from Gliese 163c into its component wavelengths. This spectroscopic analysis helps astronomers determine the planet's atmospheric composition by identifying specific molecular signatures, such as water vapor, methane, or carbon dioxide, key indicators of potential life-supporting environments. These instruments, working in concert, not only pinpoint the location and existence of planets like Gliese 163c, but also provide a detailed look at their atmospheres and possible conditions for life, ushering in a new era of exoplanet discovery. Data interpretation. Interpreting the data received from Gliese 163c is a meticulous process that begins with the initial reception of signals captured by the James Webb Space Telescope. These signals, primarily in the form of infrared light, are analyzed using a variety of computational models to determine the planet's atmospheric composition, surface temperature, and potential presence of water vapor, among other vital characteristics. The accuracy of these findings is paramount. To ensure reliability, astronomers employ several validation techniques. First, the data undergoes a peer review process, where multiple independent teams of scientists examine the findings. This collaboration helps to eliminate biases and verify the consistency of the results across different observational methods and software analyses. Additionally, the findings from Gliese 163c are cross-referenced with similar exoplanets data, providing a comparative baseline that bolsters the confidence in the interpretations. By integrating these methods, astronomers not only refine their understanding of Gliese 163c, but also enhance the broader scientific community's trust in these distant world observations. Hypothetical life forms. Gliese 163c, with its position firmly within the habitable zone of its star, ignites the imagination with possibilities of life. The conditions on this exoplanet, which closely mirror those of Earth in terms of temperature and potential water presence, lead us to consider what forms of life might thrive there. Picture, if you will, microbial life forms that have adapted to potentially extreme conditions, which could range from intense solar radiation to varying atmospheric compositions. Moreover, the possibility of more complex multicellular organisms cannot be dismissed. These organisms might possess unique adaptations to their environment, perhaps akin to extremophiles on Earth that thrive in the harshest conditions from deep sea vents to the frozen tundras. The presence of liquid water, a critical ingredient for life as we know it, could mean that aquatic life forms might dominate the biosphere of Gliese 163c. Imagine creatures that have evolved not only to survive but to flourish in the alien oceans or lakes of this distant world, developing novel biochemistries that challenge our very conception of life. Each hypothesis not only expands our understanding of biology, but also deepens the awe and mystery surrounding our universe's potential to harbor diverse life forms. What this discovery means. The discovery of Gliese 163c as a potentially habitable planet has profound implications, both scientifically and philosophically. From a scientific standpoint, this finding challenges and expands our understanding of habitable environments. It prompts a re-evaluation of how we study planetary atmospheres and climates, pushing us to develop more sophisticated models to predict and comprehend life-supporting conditions. Moreover, Gliese 163c offers a real-time laboratory for testing theories about planetary formation, evolution, and the potential for sustaining life. Philosophically, the discovery stirs profound questions about our place in the universe. The existence of another potentially habitable planet inherently suggests the possibility of life beyond Earth, which could fundamentally alter our understanding of life's uniqueness and rarity. It encourages us to reflect on our responsibilities as a species and the ethical considerations of exploring and potentially interacting with other life forms. The mere presence of such a planet invites us to ponder our solitude or kinship in the cosmos, potentially reshaping human consciousness and our philosophical outlook on life, existence, and the universe at large. Next steps in research. Building on the groundbreaking discovery of Gliese 163c, the scientific community is buzzing with plans for future missions aimed at delving deeper into this potentially habitable exoplanet. These ambitious missions are designed not only to confirm the preliminary findings about the planet's environment, but also to explore its atmosphere in much greater detail. One of the primary objectives is to analyze the atmospheric composition and look for signatures of gases like oxygen and methane that could indicate biological processes. Another focal point of upcoming missions will be to measure Gliese 163c's temperature gradients and seasonal variations, providing insights into its climate systems. This will help scientists understand whether conditions on the planet could support liquid water, a crucial ingredient for life as we know it. By deploying advanced spectroscopy and imaging techniques, these missions will capture high-resolution data, offering a clearer picture of the planet's surface and potential weather phenomena. Furthermore, astronomers hope to determine the planet's mass with greater precision. This is essential for understanding the planet's gravitational pull and its effect on potential atmospheres. Each piece of data brings us one step closer to answering the tantalizing question: could Gliese 163c be a second home for humanity, or perhaps already home to its own form of life? Through these efforts, we seek not just to discover, but to profoundly understand what lies beyond our solar system. Learning from Gliese 163c. The discovery of Gliese 163c opens up a wealth of educational opportunities and has the potential to significantly boost public interest in astronomy and exoplanetary science. As educators integrate this new information into curriculums, students and the public alike can experience firsthand the thrilling evolution of our understanding of the universe. The concept of habitable exoplanets, such as Gliese 163c, provides a concrete example of how theoretical astrophysics impacts real-world science and stokes curiosity about life beyond Earth. This discovery also serves as an excellent tool for engaging the public in science. Media coverage and popular science content that discuss Gliese 163c can help demystify the process of scientific discovery, making the field of astronomy more accessible and appealing to a broader audience. It allows for interactive discussions, workshops, and potentially even citizen science projects where amateurs can contribute to ongoing research. The excitement generated by such findings can lead to increased funding and support for further space exploration, ensuring that the study of exoplanets remains a dynamic field at the forefront of scientific inquiry. Advanced scientific theories and models. The exploration of Gliese 163c has catalyzed the development of new scientific theories and models that aim to decode the complex environments of distant exoplanets. As astronomers analyze the data gathered by the James Webb Space Telescope, they are beginning to challenge and expand existing models of planetary habitability. For instance, the traditional model that categorizes a planet's potential for life based on its distance from the star is being nuanced with more complex variables such as atmospheric composition, magnetic fields, and orbital stability. These refined models consider how the unique characteristics of Gliese 163c, like its atmospheric chemistry and potential geothermal activity, could support life in ways that differ from Earth. The study of this exoplanet also allows scientists to test theories of planet formation and evolution in the context of different star systems. This not only enriches our understanding of how planetary systems develop, but also widens our search criteria for life-sustaining planets across the galaxy. By integrating observations from Gliese 163c into broader astrophysical models, we are on the brink of potentially discovering new types of habitable environments, fundamentally shifting our understanding of where life could exist in the universe. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now. Imagine waking up tomorrow to find all technology rendered useless by a solar storm. This is not just a hypothetical scenario, it's a stark reminder of the dangers posed by variations in the sun's surface conditions. Our modern world relies heavily on reliable electricity infrastructure, communications, and navigation, all of which can be disrupted by powerful solar storms. As the world stands on the brink of technological collapse, one man steps forward with a dire warning. Bill Nye warns of an unprecedented G5 solar storm, a cataclysmic event that could plunge civilization into chaos and darkness. The question we must ask ourselves is whether our civilization is ready to withstand a disaster of this magnitude, or will we be consumed by the darkness that awaits? Join us as we explore Bill Nye's final warning about the extreme G5 solar storm. The huge solar storm that Earth has been experiencing in recent days serves as a clear illustration of the immense impact the sun has on our world. An enormous solar flare has triggered the strongest geomagnetic storm ever recorded in Earth's atmosphere. This storm has the potential to disrupt power grids, communications, and navigational systems, and could even cause the northern lights to be visible as far south as Florida and Southern California. As the sun's constant stream of radiation bombards Earth's magnetic field, the consequences may linger into the weekend. The NOAA, which keeps tabs on space weather, has issued an extraordinary storm watch, the first such advisory in 19 years, and has since raised it to a warning due to the solar activity's intensity. At least 5 of the sunspots that the organization has been tracking have begun to produce eruptions that might potentially impact Earth. The storm's most noticeable feature, the northern lights or auroras, will be seen by many people across the globe. However, governments and businesses will also be watching for how the event affects critical infrastructure such as GPS, radio communications, and power grid resilience. We had a taste of our sun's destructive effects on September 2nd, 1859. On that day, marine compasses stopped functioning, leading to the loss of some ships. Some telegraph lines caught fire, disrupting the networks. Notably, auroras were seen by folks in Mexico and the Caribbean, which is quite a ways south. What occurred on that day more than 16 decades ago was likely an intense geomagnetic storm, according to scientists today. Since then, the 1859 storm has become known as the Carrington event. The event was named after British astronomer Richard Carrington, who discovered the solar flare that caused the storm. Richard Carrington was a well-known British astronomer of the 19th century whose focus was the sun. He was the first to discover that the sun doesn't spin as a solid body, but that solar material travels quicker at its equator than at its poles. He also found out where the sun's north and south poles are. Carrington discovered that the dark spots on the sun's surface, called sunspots, vary in latitude over the 11-year solar cycle. He and Richard Hodgson saw the first bona fide solar flare. He witnessed a brilliant burst of light on September 1st, 1859, while studying sunspots. Scientific consensus today holds that he witnessed the solar system-wide shock waves caused by the massive coronal mass ejection, an explosive event that occurred close to the sun's surface and was propelled by magnetic field lines. The next day, a massive storm hit Earth's magnetic field. When the sun is in the final stages of its 11-year cycle, coronal mass ejections are more abundant on its surface. It is now standard practice for our spacecraft to record coronal mass ejections, although there were suggestions that coronal mass ejections existed in the 19th century. Their discovery was still a ways off. It wasn't until 1971 that coronal mass ejections were detected by the Helios satellite using ultraviolet studies. The Royal Astronomical Society was promptly notified of the flash by Carrington. He likely didn't give it much more consideration until the next day, when the geomagnetic field went into overdrive due to the fast-moving solar particles making their way to Earth. The solar particle burst released around 10 to 35 electron volts of energy while buffeting, compressing, and distorting Earth's magnetosphere, encasing the planet in a roaring, writhing mass of high-energy particles. That's a 10 followed by 35 zeros. This amount of energy is equal to a 10 megaton nuclear bomb and is also equal to the amount of energy the sun releases in about 10 seconds. As far as anyone knows, it was the strongest solar event in history. An urban legend claims a telegraph operator was paralyzed in one arm after waking from a shock-induced unconsciousness, though there's no evidence for this. The extreme geomagnetic storm ended the next day, and telegraph networks were repaired as the auroras faded. Understanding the 1859 event requires knowledge of the solar cycle, discovered by German amateur astronomer Samuel Heinrich Schwabe in 1843. After 17 years of observing the sun, Schwabe found that sunspots varied in an 11-year cycle. His discovery showed the sun's dynamic nature. The peak of solar cycle 10 was in February 1860, shortly after the Carrington event in September 1859. The 11-year solar cycle, driven by the sun's magnetic field, peaks when the sun's magnetic poles switch positions. During these peaks, intense solar phenomena, including coronal mass ejections, CMEs, are common. We're currently in such a period. Each CME releases about 1 billion tons of material, sometimes directed at Earth, causing geomagnetic storms. In March 1989, a major solar storm hit Quebec, Canada, knocking out power for over 9 hours and causing economic damage worth hundreds of millions. This event highlighted the vulnerability of modern infrastructure to space weather. The 2003 Halloween storms began on October 19th and reached their height just before Halloween, hence the name. Satellite communications, GPS systems, and power grids were all affected, and auroras were seen as far south as Florida and Texas. Radiation levels were so high that planes had to change their routes, and astronauts on the International Space Station had to seek refuge. The greatest violent solar storms of the first space period occurred in 2000 during the Bastille Day event, named after the French national celebration on July 14th. Approximately 24 hours after a large solar flare burst, Earth was hit by a coronal mass ejection. Intense auroras were visible across North America and Europe as a result of the storm, which also momentarily crippled a few satellites. It wreaked havoc on aviation and marine navigation by interfering with radio communications and GPS signals. One of the lesser-known but highly impactful solar storms happened in May 1921, affecting the northeastern US and parts of Europe. Geomagnetic disturbances were caused by the massive coronal mass ejection that impacted Earth. Disruptions to telegraph and telephone lines occurred, and fires broke out at some stations as a result of induced electric currents. Additionally, it disrupted transportation due to the widespread breakdown of railway signals. The current geomagnetic storm, rated G5 extreme by NOAA, is caused by a cluster of sunspots flaring and ejecting material every 6 to 12 hours. These storms, which occur when energetic particles from the sun disturb Earth's magnetic field, can cause widespread blackouts, damage infrastructure, and disrupt satellites. The scientific community is preparing for multiple impacts. Why is this happening now? The sun's activity peaks every 11 years, and we are currently at that peak. Since the cycle began in December 2019, there have been 3 major geomagnetic storms, but none were significant enough to trigger alerts. Bill Nye and NOAA officials explain that the current storm is due to the largest cluster of sunspots in this cycle, which has exceeded initial predictions. Although the sun's rotation will soon position this cluster away from Earth, it will still produce more flares and expulsions. Scientists are uncertain if these sunspots will cause more activity when they reappear in the coming weeks. Are we to be concerned? No one on Earth's surface needs to be worried about solar storms. Even though these storms are terrifying to think about, they pose no threat to humans as long as we stay on land and the atmosphere protects us. Keep in mind that since the Sun and Earth came into existence, there is every indication that solar storms have been occurring for billions of years. In that case, they would be responsible for the evolution of all life on Earth. When it comes to space, how dangerous is a solar storm? Radiation poisoning can be caused by extremely high-energy particles, which are delivered by coronal mass ejections. This includes humans and other mammals. They would be dangerous to unshielded astronauts, such as astronauts traveling to the Moon or Mars. Large doses could be fatal. Solar storms can be dangerous to our technologies, though. Charged particles from a coronal mass ejection can slam into Earth's atmosphere, damaging or even destroying orbiting satellites and exposing planes in the sky to radiation. The presence has the potential to interfere with navigational and phone systems. Entire cities and even regions have been blacked out due to their ability to disrupt power grids. People talking about power failures from solar storms always point back to March 13, 1989. This event cut off electricity to over 6 million people for 9 hours. But it's possible for solar storms to be even more powerful than the one that caused the 1989 Quebec and US Northeast blackouts, such as the Carrington event or the 1859 solar superstorm. How would our lives be affected right now if a Carrington event were to occur today? Our world is totally different now. All around us, our technology is sophisticated and cutting edge. In a world where the internet has replaced telegraph lines as the primary means of communication, our lives are more interconnected than ever before. The first undersea transatlantic telegraph cable came just a year before the Carrington event in 1858. It connected North America with Europe for the first time, allowing news to propagate around the world faster than ever before. Today, most of the world's internet traffic flows through undersea cables of vast capacity. Existing cables flow with ever-multiplying streams of ones and zeros, the telegraph songs of the digital age. Computers control many aspects of our society, from healthcare to entertainment, electricity grids to banking. Devices like toasters, TVs, telephones, and cars owe their existence to the integrated circuit. A Carrington-type event could generate massive electrical currents, leading to widespread power grid failures and electronic circuit damage, far worse than the 1989 Quebec blackout. Such a solar storm could cripple key infrastructure, impacting power, food, water, transportation, security, and communication, leaving millions without the ability to charge phones or use electronic devices. A major solar storm would cause widespread blackouts, disabling vital water supply pumps. Interconnected issues could amplify, especially if the storm hits in winter when the cold is deadly. The internet would suffer, as undersea cables crucial for global digital traffic might be damaged, limiting the internet to smaller, vulnerable private networks. The storm's impact would vary globally, influenced by factors like the power grid, water proximity, Earth's magnetic field, and local geology, which affects ground conductivity. China, the United States, and Australia are particularly vulnerable to power outages due to various factors. The metropolitan corridor from Washington, D.C. to New York City is especially at risk. Satellites in space could fail as their electronics get fried during geomagnetic storms. For instance, a coronal mass ejection in March 2022 caused the failure of 40 SpaceX Starlink satellites due to increased atmospheric drag, leading them to burn up upon re-entry. Although satellites handle only about 1% of global internet traffic, they are crucial for financial transactions, ATM operations, and banking communications. Widespread communication loss would lead to chaos and could take years to recover from. Professionals have studied how solar storms can disrupt the Earth's magnetic field, causing large currents in power lines that damage transformers and electrical systems. In the US, a major solar storm could leave tens of millions without power for weeks, months, or years, resulting in trillions in economic damage. Bill Nye argues that these estimates are vastly underestimated. Considering this, we must ask, how likely is another Carrington event? After 164 years, do such events happen sporadically or at regular intervals? Can we predict the next storm's timing and severity? Most importantly, how much warning would we have? First, we need to address the root cause of the issue, which is coronal mass ejections. Indeed, our understanding of them has greatly expanded since their discovery in 1971. On the other hand, coronal mass ejections can fool you, although they are more common during solar maximum because the sun's magnetic field reorients at that time. Our understanding of the processes that cause them is yet insufficient to predict when they will actually occur. Consequently, the likelihood of a repeat of the Carrington event is completely unknown. The frequency with which these occurrences happened prior to 1859 is similarly unknown. Such storms likely remained unrecorded prior to the invention of electric grids and equipment, with the exception of reports of spectacular auroras. How much warning could we have of a devastating storm? Scientists are aware of the risks and use AI to predict potential disasters. NASA's Dagger can alert us about 30 minutes before a storm. The sun is constantly monitored by Earth and satellites, but predicting the exact impact of a coronal mass ejection is challenging. Scientists, including those at the Space Weather Prediction Center, watch for solar storms that could affect Earth. For a solar storm to impact us, it must occur on the sun's side facing Earth, and the coronal mass ejection usually reaches us several days later. Satellites can temporarily disable their systems to avoid damage from large coronal mass ejections, and Earth-based power systems can be modified for extra grounding with prior notice. Scientists and governments are increasingly focusing on this issue, aiming to develop methods to withstand the sun's intense rays. Understanding the sun's magnetic field better is crucial for predicting future geomagnetic storms. The same precautions used to protect spaceship electronics can protect our power grids, but this requires global government action and significant funding. However, governments have yet to allocate sufficient resources to address this threat, making it unlikely they'll take the risk of another Carrington event seriously. To mitigate potential calamities, we must enhance our understanding of the Sun-Earth system, monitor solar activity, and improve space weather predictions. Better knowledge leads to more accurate forecasts, similar to regular weather predictions. Understanding the sun's complexities and its interactions with Earth is challenging. Our space weather predictions are about 50 years behind general weather forecasts. Thus, missions like the Parker Solar Probe, launched in 2018, are crucial. Parker has already uncovered how the sun transports energy, and in 2022 flew through a coronal mass ejection, providing valuable data to improve prediction accuracy. Bill Nye emphasizes the importance of determining the time as the first step in creating an early warning system to prevent disasters. However, he notes that current efforts are insufficient. The Parker probe, limited to studying the sun from one angle, can't serve as a full-time warning system. Nye suggests deploying a constellation of satellites around the sun, similar to Starlink around Earth, for comprehensive monitoring and warning. He advocates for bold, expansive ideas and risk-taking. Solar activity, while potentially destructive, may have accelerated life on Earth and protects us from more harmful cosmic radiation. Future space missions beyond Earth's magnetic field might benefit from periods of maximum solar activity. While solar storms pose significant risks, an active sun provides better protection against galactic hazards. If we could monitor and predict solar weather, we could reduce local threats and protect astronauts. Our actions now will have long-term impacts. Enhancing satellite resilience to geomagnetic storms is achievable. Following Quebec's billion-dollar investment in strengthening electrical infrastructure post-outage, the U.S. should also fortify its systems to withstand severe storms, not just weaker ones. Increased funding for solar research is a viable option. NOAA's Space Weather Follow-on L1 mission and NASA's Interstellar Mapping and Acceleration Probe, both launching in 2025, will monitor the Sun and help predict space weather. The Parker Solar Probe, making its closest approach to the Sun in late 2024, will become the fastest man-made object at 435,000 if. Its mission concludes in 2025, but its excellent condition may allow for extended operations, providing valuable data to understand the Sun and potentially mitigate the impact of future solar storms on humanity. Are we too dependent on technology, and could a disaster such as the G5 solar storm serve as a wake-up call to reevaluate our reliance on it? Thanks for watching another episode of A World to Discover. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.
We have found a terrestrial planet orbiting Proxima Centauri. It's the nearest exoplanet we will ever find.
Astronomers are exploring the cosmos like never before, thanks to the advanced James Webb Space Telescope. This marvel of technology, which launched back in 2021, has sparked a new era of cosmic discoveries, notably concerning Proxima B, the closest exoplanet to Earth, located about 4.25 light-years away in the habitable zone of the star Proxima Centauri. Proxima B, a super-Earth in the habitable zone. Understanding Proxima B's tidally locked status, where one hemisphere perpetually faces the star while the other remains in darkness, raises intriguing possibilities about its climatic conditions and the survival strategies that might be necessary for any potential life forms or future human explorers. On Earth, life depends on a stable cycle of day and night to regulate environmental and biological rhythms. In contrast, the permanent daylight on one side of Proxima B could mean environments that are continuously warm and illuminated, while the opposite side might experience perpetual night and significantly cooler temperatures. This stark contrast could affect atmospheric dynamics dramatically, potentially creating extreme weather patterns as heat from the day side tries to circulate to the night side. For a technological civilization on Proxima B, managing these conditions could involve innovative infrastructures, such as vast networks of energy, transfer systems that harness and redistribute solar energy. One could imagine a civilization using advanced technology to create a balanced climate across the planet, perhaps utilizing superconducting cables that span the globe to distribute heat and power efficiently from the illuminated side to the dark side. Such scenarios also invite us to think about the types of technology necessary to detect and interact with such potential civilizations. Our current search with instruments like the James Webb Space Telescope and studies into artificial light could one day reveal signs of such advanced technological adaptations, offering us profound insights into the adaptability of life and technology under extreme conditions. Understanding Proxima B's unique environment not only expands our knowledge of planetary sciences, but also pushes the limits of our technological imagination, laying groundwork for the kind of interstellar engineering we might someday deploy in our own cosmic ventures. Thus, Proxima B stands not just as a subject of scientific inquiry, but as a beacon that challenges our ingenuity and resourcefulness in the face of stark, celestial extremes. Hints of civilization, detecting artificial light on Proxima B. The James Webb Space Telescope's capabilities have allowed astronomers to detect what might be artificial lights emanating from Proxima B. This observation is particularly intriguing because it suggests the presence of technology, possibly a form of advanced civilization. Imagine a world where night never falls on one side, and on the other, darkness prevails perpetually. It's here, on this eternally shadowed hemisphere that we might be seeing lights that could be street lamps, buildings, or other manifestations of alien ingenuity, similar to how we light up our cities and streets. These lights are not just points of brightness. They could indicate complex energy usage and perhaps even a structured society capable of manipulating their environment significantly. If these findings are verified, this would mark the first time human technology has identified a potentially technologically advanced civilization beyond Earth. This not only expands our understanding of habitability in tight solar orbits, but also deepens the mystery surrounding these distant worlds. Such a discovery redefines not just the search for extraterrestrial life, but also the very parameters of what to look for in the cosmos. The implications of this could be profound, reshaping our search strategies and targets in the ongoing quest to find alien life. As we continue to investigate these signals, we edge closer to perhaps one day confirming the existence of other technologically advanced civilizations in the universe. Delving into Proxima B's atmosphere, the atmospheric study of Proxima B via the James Webb Space Telescope offers a rare window into conditions on a potentially habitable exoplanet. Given the high sensitivity of James Webb's instruments, astronomers can discern subtle variations in the planet's atmosphere, providing insights into its climate and chemical makeup. Proxima B's proximity to its star could lead to extreme atmospheric conditions, including high radiation levels and significant temperature variations between its day and night sides. This makes understanding its atmospheric stability and composition even more critical. Researchers focus on identifying key molecules like water vapor, carbon dioxide, and methane, which are considered essential for supporting life as we understand it. The presence of these molecules can indicate active geological or chemical processes similar to those on Earth, which could sustain an environment conducive to life. For instance, water vapor is a telltale sign of potential hydrological cycles, and methane could suggest organic activity. These detailed observations also help in modeling Proxima B's potential ecosystems and assessing how its environment has evolved over time. Are these conditions stable enough to support life? Does the atmosphere protect the surface from harmful stellar radiation? Each data point collected by the James Webb Space Telescope helps to build a more comprehensive picture of Proxima B's habitability. Ultimately, while the search for alien life is captivating, it is the meticulous study of atmospheres like that of Proxima B that grounds such searches in scientific rigor. This ongoing research not only enhances our understanding of distant worlds, but also refines our knowledge of planetary science, a critical step toward answering the age-old question of whether we are alone in the universe. The philosophical implications of discovering alien life. Exploring Proxima B transcends the scientific ambition of discovering alien life. It taps into a deeper, almost philosophical yearning that has shadowed humanity throughout history. This exoplanet, nestled in the habitable zone of the nearest star to our solar system, serves as a canvas on which we project our grandest existential inquiries. As astronomers pass through data collected by instruments like the James Webb Space Telescope, each piece of information offers a potential clue not just about the conditions on Proxima B, but also about the broader cosmic landscape that surrounds us. The implications of finding life or habitable conditions there are monumental. They would suggest that life-sustaining planets could be more common than previously thought, thereby increasing the probability that the universe teems with life. This prospect shifts our understanding of life's rarity and resilience, prompting us to reconsider our role and significance in the grand scheme of existence. Are we just a cosmic anomaly, or part of a broader, perhaps infinite tapestry of life forms? Such questions have philosophical weight, influencing everything from the search for extraterrestrial intelligence, SETI, to theoretical physics and existential philosophy. The study of Proxima B isn't just a quest for biological signatures or atmospheric analysis. It's a bridge to understanding the universe's capacity to harbor life, challenging our perceptions of loneliness and connectivity in the cosmos. In essence, as we decode the mysteries of Proxima B, we are also unraveling the narrative of human significance in an expansive, dynamic universe. The answers we find could redefine our place in the cosmos as not merely solitary travelers, but potentially as part of a much larger community of cosmic inhabitants. Breakthrough Listen, searching for signals of intelligent life. The Breakthrough Listen project, a pioneering initiative funded by ambitious visionaries, utilizes state-of-the-art radio telescopes to eavesdrop on the universe. Its primary goal is to capture electromagnetic signals that could indicate the presence of intelligent civilizations beyond Earth. Recently, their focus has turned toward Proxima B after detecting a narrow-band radio signal originating from its vicinity. This signal, peculiar due to its specific frequency pattern, closely resembles what we'd expect from a technologically advanced source. While it's far from confirmed as extraterrestrial, this development excites scientists and the public alike, as it may potentially shift our understanding of life in the universe. Each signal captured is rigorously analyzed to differentiate between possible interstellar communications and cosmic noise, ensuring that only the most promising are considered. This tantalizing glimpse into the cosmic landscape not only advances the field of astrobiology, but also deepens the enigma surrounding our nearest stellar neighbor. Such findings promise to catalyze further research, holding the potential to one day break the silence of the cosmos. Proxima B's rapid orbit and its environmental challenges. Proxima B's rapid orbit of just 11.2 days around its host star presents a unique dynamic when compared to Earth's annual journey around the Sun. This quick orbit implies that a year on Proxima B passes in what would be less than 2 weeks on Earth, drastically altering how we must approach the study of its seasons and weather patterns if such exist. Given its potential tidal locking, where one side is perpetually day and the other eternally night, understanding atmospheric circulation becomes crucial. Scientists hypothesize that if an atmosphere does exist, it could be the key to transferring heat between these two extremes, potentially allowing for a more temperate climate in the twilight zone between the harsh environments of the bright and dark sides. Such a study could offer insights into not only the climate and weather patterns on Proxima B, but also broaden our understanding of atmospheric sciences in extreme exoplanetary conditions. This could, in turn, deepen our knowledge of planetary habitability across the universe, revealing how life might adapt to conditions vastly different from those on Earth. Navigating the challenges of a hostile star. Exploring the habitability of Proxima B brings us face-to-face with the volatile nature of its host star, Proxima Centauri, an M dwarf. These stars, while abundant in our galaxy, present unique challenges for planetary habitability. M dwarfs are notorious for their violent solar flares, which can be much more frequent and powerful compared to those from our Sun. Such flares emit intense radiation that has the potential to strip away the atmosphere of planets in close orbits like Proxima B. This atmospheric stripping is critical because an atmosphere not only supports life as we know it, but also protects the surface from harmful cosmic and solar radiation. Further complicating the scenario, M dwarfs remain active longer than larger stars, meaning Proxima B is exposed to these harsh conditions for extended periods, potentially billions of years. This prolonged bombardment by solar radiation could hinder the development or sustainability of life, as continuous flare activity might prevent the planet from maintaining a stable atmosphere long enough for life to develop or sustain itself. Moreover, the high-energy particles from Proxima Centauri could erode the atmosphere's ozone layer if one exists, increasing the surface's exposure to deadly ultraviolet light. Without an ozone layer, any life forms would be vulnerable to radiation that could mutate DNA, posing another hurdle for life. These factors make the environment of Proxima B appear hostile. However, the resilience of life on Earth in extreme conditions gives us a glimmer of hope that life could adapt in ways we haven't yet imagined. Proxima B continues to captivate our curiosity and drive our exploratory efforts, each discovery bringing us closer to understanding not just other worlds, but also our own planet's resilience and the tenacity of life itself. Advanced tools for a deeper understanding. The James Webb Space Telescope, JWST, equipped with cutting-edge technologies such as the near-infrared spectrograph, NIRSpec, and the mid-infrared instrument MIRI, is revolutionizing our study of distant planets. These instruments are not just cameras or telescopes, they are finely tuned analytical tools that break down light into its spectral components. This process, known as spectroscopy, allows scientists to detect specific signatures of gases and other materials present in the atmosphere of Proxima B. NIRSpec, for example, operates in the near-infrared spectrum and can detect the faintest whispers of light coming from distant celestial objects. It analyzes the light that passes through or is emitted by a planet's atmosphere, capturing data that can reveal the presence of water vapor, methane, carbon dioxide, and other potential markers of life. This capability is vital because these compounds can suggest biological processes similar to those on Earth. MIRI complements NIRSpec by focusing on the mid-infrared spectrum, which is especially good for studying cooler objects in space. It helps astronomers study the thermal properties of Proxima B, including its temperature variations and heat distribution, which are crucial for understanding the planet's climate and weather systems. MIRI can also see through dust clouds that obscure other instruments, providing a clearer picture of the planet's surface and atmosphere. Together, these instruments provide a comprehensive view of Proxima B's atmospheric makeup and surface conditions, offering insights into whether the planet could support life as we know it. Each new piece of data brings us a step closer to understanding not just Proxima B, but the characteristics that make any planet potentially habitable. The ongoing research with JWST's instruments is gradually filling the gaps in our knowledge about Proxima B's environment, promising to eventually unlock the secrets of this intriguing world. A testament to human advancement in technology, the James Webb Space Telescope, JWST, stands as a monumental achievement in our quest to understand the cosmos. Equipped with a suite of sophisticated instruments, it peers into the farthest reaches of the galaxy with unprecedented clarity. This telescope uses infrared technology to bypass the dust and gas clouds that obscure other telescopes' views, allowing us to observe the formation of stars and planets in real time, examine the chemical composition of alien atmospheres, and possibly detect signs of life by identifying atmospheric anomalies that cannot be explained by natural processes alone. One of the most intriguing capabilities of the JWST is its potential to observe the atmospheres of distant exoplanets in such detail that we can identify the molecular signatures of water vapor, methane, and carbon dioxide. These molecules are often considered potential indicators of biological processes. By comparing these findings with our own planet's biosignature, scientists hope to uncover parallels that might suggest similar life-sustaining conditions elsewhere in the universe. This ability to look back in time and out across space provides a clearer picture of our own origins as well. By examining other solar systems at various stages of development, we gain insights into the past and future of our own planetary system. The James Webb Space Telescope not only expands our understanding of the universe, but also serves as a mirror, reflecting the possible trajectory of our own planetary destiny. With each mission and observation, JWST is rewriting textbooks on astronomy and possibly biology, bringing us steps closer to solving the ultimate mystery of our existence in this expansive universe. Expanding our cosmic horizons. The exploration of Proxima B transcends traditional astrophysics, venturing into philosophical realms as we ponder our place in the cosmos. Studying this exoplanet, particularly within its star's habitable zone, we confront the profound possibility of encountering extraterrestrial life forms. This endeavor not only sharpens our technological prowess, but also deepens our existential inquiries. By analyzing the atmospheric conditions and potential biological signatures on Proxima B, we contribute to a broader understanding of what environments can sustain life. Each discovery here influences our approach to other celestial bodies and adjusts our theories about life's prevalence in the universe, encouraging a broader reconsideration of biological possibilities beyond Earth. This ongoing research could eventually lead to a revolutionary paradigm shift in how we perceive life and intelligence in the universe. The journey of discovery continues. Now let's conclude. The exploration of Proxima B is not just a scientific endeavor, but a journey that taps into the human spirit of discovery, pushing the boundaries of technology, knowledge, and our understanding of life itself. As we peer deeper into the cosmos, each finding adds a new piece to the puzzle of our universe, ever expanding the horizons of human discovery.
The little spacecraft that could, Voyager 2, is heading for its closest encounter yet with the planet Neptune. It's now billions of miles from...
While Jupiter boasts its mesmerizing storms, Mars captivates with its potential for life, and Saturn dazzles with its stunning rings. Courtesy of the Cassini spacecraft's 13-year grand tour, Neptune seems to quietly orbit in the distant chill of space. It's the 8th planet from our Sun, remote and enigmatic, often overlooked in the bustling solar system family. So why does Neptune receive less attention compared to its planetary siblings? Let's dive deep into the blue to uncover the mysteries and majesty of this distant ice giant. Join us as we explore what makes Neptune unique and why it deserves a closer look. Named after the Roman god of the sea, Neptune is often referred to as an ice giant due to its composition, which consists primarily of hydrogen, helium, and traces of methane. With a diameter about 4 times that of Earth, Neptune boasts a striking blue hue attributed to the presence of methane in its atmosphere, which absorbs red light and reflects blue. Discovered in 1846, Neptune's exploration has been limited compared to its closer planetary counterparts. However, the historic flyby of NASA's Voyager 2 spacecraft in 1989 provided invaluable insights into this distant planet, unveiling its dynamic weather patterns, unique moons, and fascinating rings. Among its moons, Triton stands out for its retrograde orbit, moving opposite to Neptune's rotation, suggesting a complex history of capture and gravitational interactions. Neptune's atmosphere is characterized by powerful storms, including the Great Dark Spot, reminiscent of Jupiter's Great Red Spot, showcasing the planet's turbulent and dynamic nature. Despite its remote location and challenges associated with exploration, Neptune remains a target of scientific curiosity, offering valuable opportunities to expand our understanding of planetary systems and the evolution of our solar system. While Mercury often steals the spotlight in astrology due to its perceived retrograde motions, which enthusiasts often blame for disruptions and challenges, the truth is far less mystical. It's merely an optical illusion resulting from the relative positions of Earth and Mercury in their orbits. However, despite Mercury's frequent appearances in astrological discussions, Neptune remains largely overlooked. Its astrological influence, while less discussed, is equally intriguing, governing realms of dreams, intuition, and mysteries. This discrepancy between the attention given to Mercury and the relative neglect of Neptune in astrology reflects the elusive and distant nature of the latter within the solar system. It underscores the vast difference between the roles planets play in astrology and their exploration in the realms of physical science. Focus on ice giants. Neptune and Uranus, often overshadowed by their larger gas giant cousins, hold a special place in the pantheon of our solar system as ice giants. This classification stems not from their being literal ice, but from their intriguing construction, largely from substances like water, ammonia, and methane, which in the cold depths of space form icy compounds. Both planets share a similar size, being significantly larger than Earth yet smaller than Jupiter and Saturn, which places them in a unique category of their own. Their atmospheres are thick with hydrogen and helium, but it's the methane that really sets them apart, absorbing red light and giving these distant worlds their characteristic blue hues. What's particularly fascinating about Neptune and Uranus is their internal structure, which, under extreme pressures, might form diamonds from compressed carbon atoms, a phenomenon that remains a tantalizing possibility not observable on the gas giants. This unusual atmospheric and internal chemistry makes Neptune and Uranus key subjects in planetary science, offering insights into not only planetary formation and evolution, but also into conditions that are utterly alien compared to those found on terrestrial planets. The mystery of Neptune's color. In a fascinating twist of scientific inquiry, a study initially focused on the broader atmospheric characteristics of Neptune ended up shedding light on one of the planet's most captivating mysteries, its striking blue color. Led by Patrick Irwin, a planetary physicist at Oxford University, the team set out to explore the atmospheres of both Neptune and Uranus. Their research was not originally intended to delve into why Neptune exhibits such a vivid azure hue. However, the findings inadvertently provided valuable insights. The team discovered that Neptune's color is primarily due to the absorption of red light by methane in its atmosphere, which leaves behind the richer blues and greens that we see. Further analysis revealed an interesting distinction between Neptune and its celestial twin, Uranus. It turns out that Neptune has a thinner layer of methane haze compared to Uranus. This thinner haze allows for a deeper, more intense blue to emerge, setting Neptune apart in the visual spectrum of the solar system. This discovery highlights how scientific journeys can sometimes yield unexpected yet enlightening results, deepening our understanding of the planets beyond our Earth. History of exploring Neptune. Neptune's exploration story, though not as extensively documented as Mars or Jupiter's, is undeniably captivating. A pivotal moment in our comprehension of Neptune unfolded with NASA's Voyager 2 spacecraft embarking on a historic flyby in 1989. This mission stands as the sole instance where we've had the opportunity to closely observe Neptune. As Voyager 2 soared past, it bestowed upon us breathtaking images that revolutionized our perception of this distant world. It unveiled a vividly blue planet, adorned with subtle rings and intriguing moons. Among these, Triton stands out, its orbit around Neptune defying convention by moving opposite to the planet's rotation, hinting at a potentially unique origin story. Voyager 2's flyby yielded invaluable insights into Neptune's atmosphere, unveiling its dynamic weather patterns, including the remarkable discovery of the Great Dark Spot, an Earth-sized storm showcasing Neptune's tumultuous nature. This mission profoundly enriched our comprehension of the outer planets and endures as a pivotal moment in planetary science. Through Voyager 2's journey, we ventured farther into the depths of our solar system, unraveling the mysteries of Neptune and expanding our understanding of the vast celestial landscape beyond. Neptune's storms and atmospheric phenomena. Neptune's atmosphere is alive with dramatic weather phenomena, most notably its storms, which can be as captivating as they are mysterious. The most famous of these is the Great Dark Spot, discovered by NASA's Voyager 2 during its 1989 flyby. This massive storm, roughly the size of Earth, showcased the fastest winds ever recorded in our solar system, reaching speeds of up to 200 kilometers per hour. However, unlike Jupiter's Great Red Spot, which has raged for centuries, Neptune's storms show much shorter lifespans. The Great Dark Spot had completely vanished by the time the Hubble Space Telescope observed Neptune in 1994, illustrating just how quickly these colossal weather systems can change. These rapid transformations hint at a highly dynamic atmosphere where storms develop and dissipate much faster than on Jupiter. The fleeting nature of these storms poses a significant challenge for scientists trying to study them. By the time a telescope like Hubble makes a return observation, the atmospheric landscape may have completely altered. This transient behavior makes Neptune's atmosphere one of the most volatile and least understood among the solar system's giants, inviting more in-depth exploration to unravel its meteorological mysteries. Role of Triton and other moons. As we delve deeper into Neptune's celestial family, we cannot overlook Triton, Neptune's largest moon. This intriguing moon captures the imagination with its peculiar retrograde orbit, meaning it moves in the opposite direction to Neptune's rotation. This unusual path suggests a dramatic origin story for Triton, likely captured by Neptune's gravity rather than forming alongside it. Such a capture is not just a spectacle of celestial dynamics, but sheds light on the migration histories of other objects in our solar system. Triton isn't just notable for its orbit. It's slightly larger than our own moon and showcases a surface rich with geological features, pointing to a potentially vibrant past. This includes the likelihood of a subsurface ocean, making Triton a key player in Neptune's system and a target of high scientific interest. Surrounding Neptune, several other moons orbit, most of them smaller and irregularly shaped compared to Triton. These moons, along with the planet's delicate ring system, form a complex gravitational dance that influences the system's stability and evolution. Understanding these interactions helps astronomers piece together the dynamic processes governing the outer solar system, providing clues about the formation and evolution of planetary systems as a whole. Current and future observations. The James Webb Space Telescope, JWST, our most advanced space observatory, has recently turned its powerful gaze towards Neptune, offering us some of the clearest and most detailed images of this distant planet in over 3 decades. With JWST's sophisticated instruments, we're peering into the icy depths of Neptune's atmosphere and gaining unprecedented views of its intricate ring system and numerous moons. The telescope's ability to capture high-resolution images in infrared light has illuminated features that were previously too faint to discern. This includes several of Neptune's lesser-known moons and the fine particles that compose its rings, revealing new details about their composition and dynamics. These observations are crucial as they not only enhance our understanding of Neptune's physical properties, but also help astronomers piece together the planet's evolutionary history and its current meteorological phenomena. The data gathered by JWST is expected to keep scientists busy for years, unlocking secrets of the furthest reaches of our solar system. This rich influx of data from JWST marks a significant milestone in our quest to understand Neptune's complex climate system, its unique atmospheric chemistry, and its dynamic environment. Challenges in exploring Neptune. Exploring Neptune presents unique challenges, primarily due to its immense distance from the Sun, approximately 4.5 billion kilometers away. This vast expanse not only increases travel time and costs, but also poses significant technical hurdles for communication and power supply. Spacecraft venturing to Neptune must rely on radioisotope thermoelectric generators for power, as solar energy is too weak at such distances. These generators convert the heat from radioactive decay into electricity, providing a reliable source of power for the spacecraft's instruments and systems. Moreover, Neptune's remote location means that any mission there faces prolonged communication delays, complicating real-time command or data retrieval. The round-trip communication time between Earth and Neptune can range from hours to days, depending on the positions of the planets in their respective orbits. This isolation requires spacecraft systems to operate autonomously for extended periods, making them highly reliant on pre-programmed commands and onboard decision-making algorithms. Despite these difficulties, Neptune's exploration is crucial for understanding the outer solar system and uncovering the mysteries of ice giants. By studying Neptune's atmosphere, magnetic field, and moons, scientists can gain insights into planetary formation and evolution beyond the realm of terrestrial planets. However, these logistical complexities have led to Neptune being visited less frequently than its closer, and perhaps more immediately intriguing planetary neighbors like Mars and Jupiter. Nonetheless, the scientific community continues to advocate for future missions to Neptune, recognizing the invaluable knowledge they could yield about our solar system's distant frontier. Future missions and scientific goals. In the realm of planetary exploration, the scientific community has set its sights on some ambitious missions for the future, with Neptune featuring prominently in their plans. Currently, there's a lively debate about the next big target for a dedicated orbital mission in our outer solar system. While Neptune remains a candidate for exploration, the focus has somewhat shifted towards Uranus. Scientists recommend prioritizing a mission to Uranus within the next decade, citing its accessibility and the potential to yield significant scientific data swiftly. Despite this prioritization, the fascination with Neptune continues to grow, compelling the scientific community to consider a detailed exploration of this distant planet. A proposed mission plan suggests launching a spacecraft to Neptune around 2033, with an expected arrival in 2049. This timeline could be extended if Uranus is indeed chosen first, possibly pushing Neptune's close examination to the mid-2050s. The goals of these future missions are robust and revolve around a deeper understanding of the ice giants. Researchers aim to study Neptune's dynamic atmosphere, its intriguing storm systems, and its magnetic environment. Moreover, There's a strong interest in Neptune's moons, particularly Triton, with its retrograde orbit and geologically active surface, which could provide crucial insights into the solar system's history and evolution. These missions are expected to deliver groundbreaking data, helping to unravel some of the enduring mysteries of our solar system's most distant planets. Neptune occupies a unique position as the most distant major planet in our solar system, often overlooked in the race to explore closer and more accessible celestial bodies. Its status as an underappreciated giant belies the intriguing mysteries and scientific potential it holds. As the final frontier in planetary exploration, Neptune offers a gateway to understanding not only the dynamics of ice giants, but also the broader mechanisms at play in the outer reaches of our solar system. Future missions to Neptune could unravel these enigmas, enhancing our knowledge of planetary formation, evolution, and the peculiarities that govern such distant worlds. As we consider sending probes to its orbit, the lessons learned from Neptune will likely illuminate countless unknowns about our cosmic neighborhood, underlining the importance of reaching out to this distant blue planet. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
Looks at going to the moon one day and to Mars, and to get to Mars, they're going nuclear.
Imagine a world in which we are no longer limited by space and can traverse the enormous cosmic distances that previously seemed unbridgeable. Imagine spacecraft traveling faster than the speed of light as they dart across the stars, a concept that piques our curiosity and fuels our desire to explore beyond Earth. Science fiction no longer exists in this domain. Scientists are about to make discoveries that could lead to travel faster than the speed of light. We are on the verge of transforming the fantastical into the real, capable of stretching the boundaries of space and time and exploring theoretical possibilities that defy basic physics.
We call the action, which is to do with the mass of the particle and the time and the distance, so you basically calculate these little quantities.
But how much closer are we really to crossing this last obstacle? To what extent is science fiction already becoming science fact? Imagine being able to travel through space faster than the speed of light by boarding a spacecraft that looks like it belongs in your favorite action film. Once limited to fiction, this ambition is becoming more and more true thanks to the idea of warp drives, a speculative idea that might completely change space travel. The fundamental tenet of this project is a daring rejection of one of the most widely accepted theories in physics. Einstein's claim that nothing can travel faster than the speed of light. In accordance with Einstein's theories of relativity, an object's mass increases exponentially as it gets closer to the speed of light and needs an endless supply of energy to move forward. Humanity has long been forced to travel across the vast reaches of space at the glacial rate of conventional propulsion because to this barrier, which appears to be insurmountable. This brings us to the Alcubierre drive, an idea that originated in physicist Miguel Alcubierre's academic endeavors rather than science fiction. Alcubierre put up a method that bends space-time itself rather than trying to exceed the cosmic speed limit, drawing inspiration from the visionary leaps of science fiction. Imagine compressing space in front of a spaceship and extending space behind it, all while enclosing it in a bubble of flat space-time. By staying in a pocket of space unaffected by relativity, this manipulation allows the spaceship to travel ahead and ride the wave of warped space-time at effective speeds faster than light. Unquestionably enchanting, the Alcubierre drive offers a ticket to the skies. However, there are many theoretical and practical obstacles in the way of turning an idea into reality. Because the drive needs exotic matter or negative energy, it operates at the edge of physics, where the existence of such materials is still up for debate. Furthermore, this innovative kind of transportation is beyond the reach of existing technology due to the enormous amounts of energy required to control space-time on this scale. Warp drive technology, in spite of difficulties, symbolizes human inventiveness and our unwavering desire to explore. signaling the beginning of star-crossing expeditions as a tribute to our boundless potential and the ever-expanding boundaries of knowledge. Historical leap, the Concorde and its legacy. The Concorde is remembered in the annals of aviation history as a shining example of human inventiveness and the relentless pursuit of breaking boundaries. This supersonic passenger plane accomplished exploits that were previously only found in science fiction, completely redefining what it meant to fly over the sky. The Concorde, with its streamlined appearance and powerful engines, cut the time it took for traditional jet travel in half and made far-flung continents accessible in just 3.5 hours from Paris to New York. Nevertheless, despite its grandeur and speed, the Concorde had many drawbacks. Its only options were over the ocean, far from populated regions where the noise may disturb people due to the loudness of its engines and the sonic booms it left behind. Its retirement was also a result of its high operational expenses and the financial difficulties of maintaining such speed for commercial travel. But Concorde's legacy stood untarnished, marking a significant turning point in the race to conquer the sky and push the envelope of what was thought to be feasible. Curiosity and inspiration from the Concorde caused humanity to turn its attention from the skies to the stars, where they began investigating warp drives and space-time bending in an attempt to conduct interstellar travel, pioneering faster-than-light travel. Humanity is on the verge of making science fiction's fantasies a reality through our mission to colonize the vast reaches of space. Science and fantasy alike have long been enthralled with the notion of warping space and time itself to accelerate our craft faster than the speed of light in the cosmos. Experts in theoretical physics are now closely examining this idea, which looks like it could have been lifted from a science fiction book. It's amazing to see how the world of science fiction has impacted and inspired actual scientific investigations into the viability of warp drives. Interstellar travel has become a reality thanks to shows like Star Trek and the imaginative writings of authors like Gene Roddenberry and John W. Campbell. These works have also introduced the concept of the warp drive, a fantastic engine that can propel a spaceship faster than the speed of light to a wider audience. What was previously only a whimsical thought in the minds of artists has now provoked serious debates and theoretical investigations within the scientific community. In the 1990s, physicists began to view the ideas outlined by Einstein's theories as puzzles to be solved or opportunities to be taken advantage of, rather than as impassable obstacles that would never be overcome. This marked the beginning of the move from fiction to theoretical possibility. The difficulty was obvious. Could we not figure out a method to bend space-time itself, making shortcuts that would let us jump across cosmic distances in the blink of an eye, given that nothing can move faster than light within it? This bold inquiry has sparked an intriguing voyage of exploration that is expanding our knowledge of the cosmos and our role in it. Combination of science fiction, creativity, and modern research in the field of faster-than-light travel blurs the boundaries between the feasible and the impractical, bringing us one step closer to fulfilling the dream of space travel. Warp drive, from fiction to theoretical possibility. The transition from fiction to theoretical potential in the field of space travel frequently starts with an imaginative spark kindled by the stories we tell. Science fiction was full of ideas like warp drive, which imagined a time when people could travel across space faster than light and even faster than the speed of sound. Once limited to the pages of books and movie screens, this concept has drawn interest from scientists and grown into a ray of hope for intergalactic travel. How do we overcome the colossal barriers that stand in our way is just as important as can we when it comes to the task of traveling faster than the speed of light. Undoubtedly, energy is the most critical of these impediments. The speed of light is the ultimate speed limit of the cosmos according to the equations governing modern physics, which are based on Einstein's theories of relativity. According to our current understanding of physics, an endless amount of energy would be necessary to push an item at the speed of light, a frightening prospect that puts such undertakings in the realm of the impossible. Nonetheless, scientists are starting to look for answers on the outer edges of theoretical physics after being motivated by the creative leap of science fiction. There is some hope in the warp drive hypothesis, especially in the model put forth by physicist Miguel Alcubierre. Rather than challenging Einstein's speed restriction, Alcubierre's model suggests a workaround. If space travel isn't possible at a faster speed than light, then perhaps space can be made to move. A warp bubble that propels a spacecraft at essentially faster than light speeds might theoretically be created by shrinking space in front of the vehicle and expanding it behind. Negative energy or negative mass, which are not present in nature and whose very presence is considered exotic, is needed for this approach of bending space. The obstacles to developing a warp drive are enormous and go beyond energy needs to include the technical difficulties of modifying spacetime itself. How can the negative energy needed to create a warp bubble be produced and controlled? Which substances are resistant to the strains involved in this kind of operation? Crucially, how can we guarantee the viability and safety of traveling faster than the speed of light for the cosmos as a whole, as well as the courageous individuals aboard these cutting-edge ships? The distinction between science and fiction becomes increasingly hazy as we go across space, as evidenced by the development of the warp drive from theoretical concept to working machine, the Alcubierre drive and beyond. Miguel Alcubierre, a physicist, came up with the intriguing theoretical idea of the Alcubierre drive, which would bend space-time itself and send humanity rocketing into far-off stars almost instantly. It's like riding waves of space-time, only instead of traveling through space, we can change space itself, making it possible for us to travel faster than light and across great distances. But even as the prospect of interplanetary travel shines brightly in our eyes, there are great obstacles in our way. The most difficult riddle: the amount of energy needed. According to theoretical calculations, producing the warp bubble would require mass and energy comparable to that of Jupiter, which is an enormous undertaking that beyond both our existing technological capacities and physics knowledge. Furthermore, the drive is predicated on the presence of negative matter, a material whose repellent gravitational qualities defy common sense. Although the theoretical foundations of negative matter provide some optimism, its elusiveness has kept it just out of reach for science, existing only in the intricate mathematical formulas of theoretical physics rather than in observable reality. The universe's boundless potential is revealed as scientists negotiate the challenges of warp drive technology and the hunt for negative matter on this difficult but inspiring adventure to revolutionize space travel. Innovations in warp drive research. JWST, Eric Lentz and Harold Sonny White have made significant contributions to the dynamic field of warp drive research, which is devoted to connecting science fiction and reality. Using solitons, self-maintaining warp bubbles. Dr. Lentz, a theoretical physicist at the University of Göttingen, presents a novel approach to traveling faster than light. This method avoids the traditional requirement for exotic matter and instead suggests a workable solution powered by positive energy densities already within our reach. In the meantime, the Limitless Space Institute is led by Dr. Harold Sonny White, a former NASA employee who has played a key role in advancing the theoretical idea of warp drives toward real-world testing. The finding by Dr. White of naturally occurring small warp bubbles in the Casimir cavity, which is formed by pressing two metal plates together in a vacuum, suggests that it may be possible to enlarge these structures to a size suitable for use in space exploration. This finding not only validates the warp drive theory, but also provides fresh directions for future investigations into the creation and manipulation of these warp bubbles. JWST, Lentz and White are making great strides toward enabling access to the stars through inventive physics and engineering with their groundbreaking work in warp drive development, which is closing the gap between the ideals of interstellar exploration and reality. Reality check. Our current capabilities. The boundaries between the realistic and the fantastical are frequently blurred in the field of space exploration, particularly when discussing the idea of traveling through space at warp speed, a notion that was previously only seen in science fiction books. We are captivated by the idea of reaching the stars during our lifetimes by surpassing the speed of light, the cosmic speed limit. For the time being, though, let's return to the present and the enormous, incomprehensible stretches of space that confront us, pushing the boundaries of our technical capabilities to the absolute maximum. The Parker Solar Probe, our fastest spacecraft to date, reaches an astounding 700,000 kilometers / a small fraction of the speed of light. To put this into perspective, it would take more than 6,500 years to travel to Proxima Centauri, our nearest star neighbor, even at this astounding speed. We imagine speeds that can exceed the speed of light when we discuss warp drives and folding space, which would enable us to travel across galaxies in an instant. However, the sobering truth of our current state of affairs presents a different image. Not only is the immensity of space intimidating, but it also serves as a sobering reminder of our small place in the cosmos. The distances involved are enormous, mind-boggling, not simply huge. Furthermore, our most sophisticated rockets and probes hardly even scrape the surface of the cosmic ocean, despite the tantalizing prospect of warp drive shortcuts presented by our theoretical models of spacetime. This sobering reality check is supposed to strengthen our commitment rather than lower our spirits. Every generation builds on the foundation set by the one before it, pushing the envelope of what is possible even farther. With aspirations of traveling faster than the speed of light, we stand on the shoulders of giants today and gaze out into space. However, it's crucial to keep in mind that the slow, sometimes agonizing advancements in knowledge and technology are what set us on our path to the stars. We pay tribute to our current space pioneers who, with every tiny but important step, overcome obstacles to bring the far stars within reach, bringing in a new period of unheard of growth, creativity, and discovery as we look forward to the days of warp drives and interstellar travel. Mars, humanity's next frontier. Looking beyond Earth, Mars represents the next great step forward for humanity on its cosmic voyage. Scientists, dreamers, and adventurers have all been enthralled with this mysterious crimson planet, shrouded in mystery and charm. In addition to being a monument to human tenacity and inventiveness, our mission to colonize Mars serves as a link to comprehend our place in the cosmos. The narrative of nations keen to leave their marks on space exploration history is one of victories and losses along the way to Mars. In an effort shrouded in secret, the Soviet Union was the first to reach out toward Mars. Despite its great ambitions, the Mars 1 mission ended in quiet when contact was lost. However, this did not dampen the spirit of inquiry. After it came Mars 2 and Mars 3, which, despite the latter's brief communication, were humanity's first visits to the Martian surface. In the present day, the terrain of Martian exploration is a patchwork of global endeavors. With the help of its Curiosity and Perseverance rovers, the United States has shed light on Mars geology and the possibility of extraterrestrial life. Equipped with state-of-the-art tools, these pioneering mechanical people navigate the Martian landscape and reveal mysteries that have been hidden for ages. Europe has also turned its attention to Mars, joining forces with Russia to launch the ExoMars mission with the goal of deciphering Martian methane and any biosignatures. The mission highlights a global desire to reach beyond our earthly bounds, even in the face of geopolitical tensions and the challenging conditions of space travel. The story of Mars exploration embodies the human spirit's unwavering quest for knowledge and our ability to dream big, as it captures the evolution of international rivalries into partnerships, technological achievements, and the indomitable human spirit. Soviet Union's secret success and the race to Mars. A covert race to the stars took place in the midst of the Cold War, out of the public sight. Driven by its spirit of innovation in space research, the Soviet Union set out on a quest that would subtly leave its mark on the history of interplanetary exploration. The Soviet Union had the audacity and the covertness to aim higher, towards the red soil of Mars, while the rest of the world was focused on the Moon. A significant, though little known, chapter in space history began in 1971. For the first time ever, a successful landing on the red planet was accomplished by the Soviet spacecraft Mars 3. There was, however, hush surrounding this incredible achievement. The expedition was decided to remain secret when the probe, having only communicated data back to Earth for a few seconds, failed due to the harsh Martian environment. The Soviet Union had anticipated a success that would eclipse the American moon landings, but instead, they witnessed a quiet victory that was only acknowledged by a select group of people in the upper echelons of Soviet politics and science. This covert accomplishment highlighted the fierce rivalry that defined Cold War-era space exploration. Every superpower desired scientific advancement as much as the enhanced geopolitical status that accompanied every significant space exploration achievement. While not as well known as their American counterparts, the Soviet Mars missions demonstrated a strong dedication to expanding human knowledge and capabilities. However, the quiet surrounding the Soviet Union's Martian experiments also reflected the larger character of the space race, which was characterized by amazing achievements made in the shadow of competition. The Soviet Union's covert Mars mission revealed a new chapter in space exploration history, offering a platform for not just rivalry, but also exploration and amazement beyond our planet's boundaries. The enduring legacy of the covert Cold War Mars missions demonstrates human ambition and curiosity, serving as a constant reminder of the infinite potential of space and motivation for our ongoing exploration of the unknown, the future of interstellar travel and Mars colonization. The prospects for interstellar travel and Mars settlement are endless as we approach the dawn of a new age in space exploration. The greatest minds in theoretical physics are currently delving into the unrelenting quest for faster-than-light travel, which was formerly limited to science fiction books. Visionaries such as Miguel Alcubierre have promoted the idea of bending space-time to our whim, which offers an alluring portal to the stars. Researchers like Durst, Eric Lentz, and Harold Sonny White are working hard to make the warp drive a reality, and it is no longer just a sci-fi fantasy. These developments portend a time when light-years-long travel distances could be completed in the blink of an eye. Concurrent with the aspiration to surpass the speed of light is the grand project of settling on Mars. For many years, the red planet has captured the attention of people because to its bleak beauty and possibility of fresh starts. In addition to offering priceless insights into the temperature, geology, and possibility of life on Mars, recent missions have established the foundation for human habitation. The combination of private companies like SpaceX, led by Elon Musk, and international space agencies is driving the dream of Mars colonization ahead. Musk hopes to establish a long-term human presence on the planet during our lifetimes. This joint effort represents a cosmic giant leap for humanity, similar to the evolution from hunter-gatherer tribes to agricultural civilizations. Still, the trip to Mars is only the start. The possibility of exploring space beyond Mars and into the larger galaxy is becoming more and more realistic as our knowledge of science and technology advances. The finding of exoplanets in habitable zones around far-off stars has created new opportunities for research and possibly even habitation. These celestial bodies might provide new places for humans to live, assuring our survival and the continuance of our galactic exploration and learning endeavors. In conclusion, the prospect of Mars settlement and interstellar travel serves as a constant reminder of our enduring urge to explore the unknown, in addition to serving as a monument to human creativity and tenacity. The opportunities are endless as we approach the edge of this new territory. The stars are lighthouses pointing us in the direction of our destiny amid them, not merely spots of light in the night sky. Although the road ahead is full of obstacles, we approach it with hope and the unwavering spirit of discovery that makes us who we are. Not on Earth, but in the dusty red soil of Mars and beyond, into the wide, unexplored reaches of our cosmos,
lies the next chapter in the history of humanity.
If we make contact with them, I think in this century, we'll probably pick up signals from an extraterrestrial civilization.
In the huge space out there, a strange thing called Oumuamua got everyone talking in 2017. Guess what? It's back, and Elon Musk just revealed a big surprise: it's got company. Musk says it might crash into Earth super hard, like a whopping 1,000 atomic bombs. Scientists are scratching their heads. Is it going to smash into an alien spaceship from outer space? What mysteries is Oumuamua hiding? And how might it shake things up on our planet? Join us as we dig into the secrets of this space happening, exploring the unknown parts of space and unfolding the tale of Oumuamua's comeback. Before we move on, make sure to check out Expedia's limited member offers on flights and hotels. Check out the link in bio. It's absolutely free to become a member. Let's move on. Some scientists believe that Oumuamua could be an alien light sail, a spacecraft that uses sunlight for power. This is because Oumuamua has several unusual characteristics. It accelerates faster than expected as it approaches the sun. This could be explained by the pressure of sunlight pushing on a light sail. It has an elongated, cigar-shaped shape, which would be a good shape for a light sail. It is on a trajectory that will take it out of our solar system and never return. This is consistent with the trajectory of a spacecraft that is being propelled by sunlight. If Oumuamua is indeed an alien light sail, it would be the first concrete evidence that we have of intelligent life beyond Earth. It would also mean that alien civilizations have developed the technology to travel between stars. However, it is important to note that the theory that Oumuamua is an alien light sail is still speculative. More research is needed to confirm or deny this theory. It is likely made up of ice and rock, but it is not like a comet or an asteroid. Oumuamua accelerated as it got closer to the Sun, but it did not have a tail. Also, its path is consistent with an object made of ice and rock that is being pushed by sunlight. One possible explanation is that Oumuamua is a piece of a comet that was ejected from another solar system. As it traveled through space, the ice on Oumuamua evaporated, but the rock remained. This would explain why Oumuamua accelerated as it got closer to the Sun, but it did not have a tail. It would also explain why Oumuamua is on a path that will take it out of our solar system and never return. Another possibility is that Oumuamua is a type of object that we have never seen before. It could be a piece of an asteroid that was ejected from another solar system, or it could be something else entirely. First encounter. Our journey into the cosmos unfolds on October 19, 2017. When astronomers at the Pan-STARRS telescope in Hawaii made an intriguing discovery, Oumuamua. This cosmic traveler raced through our solar system at an astonishing speed of 320,000 kilometers per hour, sparking the curiosity of scientists worldwide. The big question: was it a comet, an asteroid, or something completely new? This cosmic puzzle led scientists to rethink what they thought they knew about space. Oumuamua challenges our understanding of the universe, prompting us to ask new questions and explore beyond our previous limits. Its unique characteristics invite us to ponder the mysteries that exist in the vastness of space. This cosmic anomaly is like an invitation to embark on a journey of discovery, encouraging us to unravel the secrets hidden in the cosmic universe. Oumuamua's secrets. As Oumuamua traveled through our solar system, scientists closely watched its strange movements. What surprised everyone was that it sped up more than they expected, making things even more interesting. Unlike typical comets, Oumuamua had a long shape and didn't have the usual tail, leaving scientists puzzled. People came up with different ideas to explain it, from thinking it might be using solid hydrogen for power to imagining it as a light sail made by aliens. Even Elon Musk got involved, suggesting there might be hidden secrets in Oumuamua, sparking conversations about the chance of life beyond our solar system. Oumuamua's journey challenges what we know about space objects, and it encourages us to think about the mysteries that might be out there in the vastness of the cosmos. It's not just a scientific puzzle, it's also a chance to explore the idea of life beyond our own celestial neighborhood. The controversial theories. In the scientific landscape of 2018, Dr. Shmuel Bialy and Professor Avi Loeb proposed a thought-provoking theory about Oumuamua. They suggested it might be a light sail, a spacecraft powered by sunlight, presenting a unique idea in space exploration. While some scientists were doubtful initially, the theory sparked discussions about Oumuamua's peculiar characteristics. Some thought it could be a sign of extraterrestrial origin, shaking up our understanding of the universe. Others were more cautious, suggesting the need for more evidence. This variety of opinions added an interesting layer to the ongoing exploration of Oumuamua, highlighting its complex and intriguing nature. The Bialy and Loeb theory not only challenged our usual ideas about celestial objects, but also prompted scientists to think about what encountering something from outside our solar system could mean. Oumuamua's return. Fast forward to the present day, and Oumuamua has made a dazzling comeback to our solar system. Elon Musk's recent announcement about the looming possibility of a direct collision with Earth has sparked fresh discussions about the true nature of this celestial visitor. As scientists wrestle with this revelation, the general public is buzzing with speculation about what an encounter with extraterrestrial forces might mean for us. Oumuamua's return has thrown the cosmic spotlight back on, prompting a renewed exploration of its characteristics and trajectory. This unexpected development has everyone, from experts to enthusiasts, captivated by the unfolding mysteries that Oumuamua brings to our cosmic doorstep. The reappearance of Oumuamua adds a thrilling new chapter to the ongoing cosmic tale, inviting us all to ponder the unknowns that lie within the realms of space. Perspectives and skepticism. In the science world, specialists hold varying opinions about Oumuamua. Neil deGrasse Tyson, an expert in space, advises caution, suggesting we shouldn't hastily connect it to aliens. In contrast, Elon Musk entertains the idea that aliens might exist. This difference in perspectives prompts conversations among everyday people about Oumuamua and its potential implications for Earth. It's akin to a widespread discussion about space mysteries, pondering what might exist in the vast, uncharted expanses of the universe. These talks inspire us to contemplate the mysteries of space and the possibility of life beyond our familiar celestial borders. Ongoing research and future discoveries. As scientists keep studying Oumuamua, they're discovering more about it. The Spitzer Space Telescope, which looks at infrared light, is helping us figure out what this strange object is made of. Astronomers are also trying to figure out where Oumuamua came from, and it looks like it had a complicated journey through our galaxy. People are talking about it again because Oumuamua's return is making scientists discuss other things in space, and whether we might come across something from outer space. This renewed interest in Oumuamua is sparking conversations not just about this specific object, but also about broader topics in space exploration. As we explore space, the mysterious Oumuamua captures our attention, challenging what we know about the universe. Scientists are trying to figure out if Oumuamua is just a natural space thing or a sign of aliens. This journey to understand Oumuamua is like an ongoing space adventure, with scientists making new discoveries and adding more pieces to the space puzzle. The exploration into the cosmos, guided by Oumuamua's presence, invites us to dig into the cosmic mysteries that are waiting for us to uncover. If you enjoyed this journey through space, please give this video a thumbs up and subscribe to our channel. More astonishing facts await, and a world to discover is here to bring them to you. Join us as we continue to explore the wonders of our world. Again, if you are planning a vacation, you can book your next trip on Expedia by visiting the link in the description below. Right now, you can save 10% or more if you are a member, with thousands of hotels to choose from. Also, members save up to 30% when you add a hotel to a flight. It's free to become a member, so hit the link in description to book your next travel adventure.